Hi everyone, welcome to Go Classes. In this session, we will continue our relational algebra summary. So this is part 2 of relational algebra complete summary. Now let's start. So let's see first writing relational algebra queries. Okay, consider this Twitter database. You can see follows. Okay, the table name is follows. Okay, so for simplicity, we will call it T. For simplicity, we will call it T. Okay, so you can see this is a Twitter database follows. Who is following whom? Okay, you can see P name, P name 1, P name 2 means person P name 1 follows person P name 2. Okay, so for simplicity, we will call it T, and this P name 1 we will call it UID 1, and pname 2 we will call it uid2. Okay, and you can see what is the primary key here. The primary key is this combination. Okay, you can see this combination is the primary key, you can see here. Okay, so here you can see that a follows b, right? Okay, I can say that a follows b. On Twitter, a follows b. You can see here I can say b follows a. Okay, b follows a. You can see a follows c, but c does not follow a, right? Yes or no? You can easily see that a follows c, but c does not follow a. C follows b, c follows b, and b follows c. Okay, so very simple. This is the idea. This is the Twitter database. Now we are going to write some relational algebra queries. Okay, so let's write the relational algebra query for this statement, for this problem. Find all people whom A follows. Okay. So tell me how to write the relational algebra query for this statement. From the Twitter database, find all people whom A follows. Means those people whom this person A follows. So what is the idea first? First, what is the idea? You tell me about the idea. Tell me one thing. Tell me one thing. Can a single tuple tell you? Can a single tuple tell you whether A follows B or not? Can a single tuple tell you? Like for example, this single tuple, can it give you whom A is following? Yes, this can give you whom A is following. Yes or no? This tuple is giving you that A is following B. This tuple is giving you A is following C. So single tuple is enough. To solve this problem, single tuple is enough. So what is the idea? Remember, the idea is very simple, that in this table T, where you have UID1 and UID2, in this table T, basically we want those whom A is following. Means we want that this UID1 should be A. Yes or no? Agree? This is the idea, that we want that UID1, this should be A. Okay, this should be fixed, this should be A. And finally, this is what we want in the output. Do you agree with me? This is what we want to project. Okay, means this person we want to project. Is this clear? Please tell me. Let me know. So very easily you can do this. What you will do? Tell me. From this table T, you will select those tuples where UID1 is equal to A. Correct? Yes or no? You will select those tuples where UID1 that is equal to A. And then finally, what you will do? You will project. We will project. We will project UID2. Okay, very simple. So this is the answer. Basically, from this table, we will select those tuples where UID1 is equal to A. So this tuple, we will select, this tuple, we will select, and then we will project these people. These two people we will project. Okay. So the answer will be B, comma C. We will project this UID2. Okay, very simple. Now let's solve this. Find all people who follow A. So tell me what is the idea here. You let me know what is the idea. So the idea is again very simple. We want from this table, we have UID1, UID2. Okay, we want those people who follow A. Okay, so these people we want who follow A, means this is the idea that in this tuple, this second column, this must be A. Yes or no? This must be fixed. This must be fixed. Okay, and finally I can say these people who follow A, I will project. So this I will project. I want those people who follow A. Okay, so this is what I will project. So very simple. The idea is that from this table T, I will select those tuples where UID2 is equal to A. UID2 is equal to A, and then what I will do, I will project UID1. This is what I will project. Yes or no? Very simple. Now let's see. Now let's see this question. Find all people who follow at least two different people. Those people who follow at least two different people. Please tell me, from a single tuple, can you find those people who follow at least two different people? Can a single tuple give you this information? Tell me, how many tuples you need to see? How many tuples? How many tuples give this information? Tell me, how many tuples give this information? Let me know. Two tuples, yes or no? For this information, two tuples you need. Do you agree with me? Okay. So we need two tuples because we want those people who follow at least two different people. Okay. So for this information, we need to see two tuples. For example, A follows B. Okay. So you can see A follows B, A follows C. So these two tuples will give me that A follows at least two different people. Yes or no? Similarly, from this tuple and from this tuple, I will find that, okay, B follows at least two different people. Correct? Okay. Agree? And you can see that C does not follow at least two different people. Okay. So here the answer should be what? The answer should be B comma A comma B. The answer should be A comma B because they follow at least two different people. Very simple. So this is the idea. Now, once you have this idea, then how to solve this question? Very simple. Okay. Let's see. The idea is like this. Basically, you take two copies of this table T. Yes or no? Okay. You take two copies of table T. So let's take table T1, or maybe you can say R comma S. For example, take two, basically, okay, let's take T1. Okay, UID1, UID2. Okay, similarly, table T2, UID1, UID2. Basically, you take two copies of the same table. Now, which tuples we are looking for in this cross product? We will do the cross product of these two. Okay, we will do this cross product. In this cross product, which tuple we are looking for? We are looking for those people, means for example this person A should follow at least two different people. So this type of tuple we are looking for, where this person, okay, this person, if a person is here, let's assume some person is here, then this same person should be here, and and this person should follow two different people. So very simple point, that these two must be different. Okay, these two must be different, and these two must be same. Okay, yes or no? These two must be same. I can say this x and this x, they must be same. And finally, what we want to project? We want to project this. This is what I want to project. Okay, very simple. So tell me, first of all, how to create two copies of table T? I want to create two copies of table T. This is what I want. I want two copies of table T, T1, T2. How to do that? Renaming, yes or no? So first of all, I will rename this table T as T1. I will do cross product with, I will do cross product with, okay, this table T, I will rename as T2. Yes or no? Do you agree? So first I am doing the renaming and cross product. In this renaming and cross product, now what I want, let me know. In this, what I want to select those tuples. I want to select those tuples. Select those tuples where you can see T1 dot UID1. T1 dot UID1 should be equal to T2 dot UID1, and and okay, I can say this is the symbol for and. You can see. Is this clear so far? Please tell me. So this is one condition. Okay, I want this UID1 equal to this UID1, and what should happen? And this would happen that T1 dot UID2 should be different from T2 dot UID2. Okay, so this is what should happen. Now, finally, once you have this, then we will project. Tell me what we will project. From here, we will project UID1, T1 dot UID1. Please tell me, did you understand? Let me know. So once you know the idea, then easily you can solve the question. Yes or no? Very easily you can solve the question once you know the idea. So this is how you can do. We want those people who follow at least two different people. Okay, so we want this type of tuple where this x, you can see this x is following to different people. Yes or no? This type of tuple we are looking for. If this type of tuple is there, then I want X in the output. Okay, I will project this UID1. Please tell me, is this point clear? Now let me know one thing. Here, does it mean that X follows exactly two people, or does it mean X follows at least two people? Please tell me. Does it mean, like here, Y, Z, does it mean X follows exactly two different people, or X follows at least two different people? It means at least two different people, because this type of tuple we are looking for. At least one tuple of this type we want. Yes or no? Is this clear? At least one tuple of this type we want. Okay, so remember, this will mean that X follows at least two different people. Okay, because remember, there can be another tuple where X is following Z comma S. Okay, this type of tuple also can be there. Means X can follow many people. Okay, for example, I am saying that in this T1 cross T2, this type of tuples are fine. For example, X is following Y, X is following Z. Okay, also this can be there. For example, X is following M, X is following N. Okay, are you getting my point? But one tuple is enough. Yes or no? This tuple is enough to say that X is following at least two different people. Is this clear? This tuple is enough to say that X follows at least two different people. Okay, one tuple is enough. Is this clear? Very simple. So there can be this type of tuple. For example, X follows Y, X follows P. Okay, so like this. But this type of tuple is enough to say that X follows at least two different people. Okay, so this will be the query. Very simple. Now let's move on. Now tell me, I want those people who follow at least three different people. How to do that? I want those where who follow at least three different people. For example, maybe A follows D also. Okay, let's assume that A follows D also. Okay, A follows D. So basically, I want those people who follow at least three different people. So what is the idea? Let me know. Now I need to take three copies of table T. Yes or no? T1, T2, T3. Do you agree with me? I want user 1, user 2, user 1, user 2, user 1, user 2. Okay, yes or no? I want three copies of table T. This is what I want. And I will do their cross product. I will do their cross product. Yes or no? Now, in this cross product, which type of tuple I am looking for? Please tell me. I want this type of tuple where this X, this X follows at least three different people. Y, Z, P. Yes or no? So what is the condition? The condition is that these three people, they should be different. For example, this should be different from this. Okay, this should be different from this, and you can see this should be different from this. Okay, correct. And remember, they must be same. This must be equal to this, and this must be equal to this. Okay, so I can say that this should happen. They must be equal. Okay, so let me write it that these two must be equal, and these two must be equal. And finally, I will project this. Please tell me, is this clear? The idea is clear to everyone. So very simple. What you will do? First, you will create three copies of table T. This table T, you will create three copies. So renaming you can use. You can use the renaming. Okay, this cross renaming you can use. I will create three copies. Okay, so remember, you can use renaming. This renaming operation you can use. So three copies I have created. After creating these three copies, I will select those tuples. Okay, selection condition I will apply. Where what should happen? This should happen that T1 dot UID1, this should be equal to T2 dot UID1. Okay, this should happen. And what should happen? T2 dot UID1 should be equal to T3 dot UID1. And what should happen? T1 dot UID2 should be different from T2 dot UID2. And T2 dot UID2 should be different from T3 dot UID2. And T1 dot UID2 should be different from T3 dot UID2. Okay, this is what should happen. Now, once this is done, Now once this is done, now I will project t1 dot uid1. Is this clear? So this is the answer. Very simple. Now tell me the answer for this question. I want all pairs of people who follow each other. All pairs of people I want who follow each other. Okay, who follow each other. Then tell me, basically, I want what answer I am looking for. Please tell me what answer I am looking for. I am looking for this type of answer where, like AB. Yes or no? I am looking for where A is following B, B is following A. Yes or no? Like, for example, AB, BA. Okay, both are fine. I want pairs of people who follow each other, like AB, BA. Okay, like BC, CB. But you can see, I don't want AC. I don't want this. Yes or no? Okay, this is what I want to discard. Is this clear? So this is the output I want. Agree? Please tell me. Okay. Now tell me what I will do. How many tuples I need? You just tell me this point. How many copies of this table I need? Two copies. Yes or no? Okay. Because two tuples will give me this information. Please notice this tuple and this tuple is giving me information that they follow each other. See, this information is given by two tuples. Given by two tuples. Okay. So it means I need two copies of table T1. Table T. Okay, I need two copies of table T. So it is like this. I will take two copies, remember. Okay. So here T1 copy I will take where you have UID1, UID2. Okay. T2 copy I will take where you have UID1, UID2. So two copies of this table I will take. I will do their cross product. Now in this cross product, which type of tuple I am looking for? I am looking for those tuples where, remember, this X should follow Y and Y should follow X. Do you agree with me? I am looking for this type of tuple where X is following Y, Y is following X. Okay, this type of tuple I am looking for. Okay, so very simple that this must be equal to this one and this must be equal to this one. Okay, then finally what I will project, please tell me. I will project these two. These two I will project. Okay, so finally the answer will be what? So you can see that first you check how many rows will give you your desired answer. So you know that two tuples will give me my desired answer. Yes or no? My desired answer will be given by two tuples of T. Two tuples of T. Okay. For example, you can see A follows B, B follows A. So two tuples of T is giving me my desired answer. Okay. Because two tuples of T is giving me desired answer. So it means I need two copies of table T. Okay. Correct. So use two copies of table T. Table T. Very simple. So finally the query will be, the answer will be like this. Okay, what you do? You create this T1 copy. Okay, cross product. You create this T2 copy. Two copies you create. Once you have created these two copies, then what you do? You select those tuples where T1.uid1. This should be equal to T2.uid2. Okay, and this should happen. And what should happen? T1.uid2. This should be equal to T2.uid1. Okay, and once these two things happen, okay, then I will project T1.uid1, T1.uid2. This is my answer. Yes or no? Very simple. Clear? Is this clear to everyone? Tell me the answer for this pairs of people who follow each other. So this we have already seen. Okay. Now let's move on. So very simple. Find all true friends in the Twitter. True friends means who follow each other. Who follow each other. Okay. So I told you that you need to create two copies of table T. So here you can see I am creating two copies of table T. One is R, another S. And the answer will be, I will select those tuples where R.uid1 equal to S.uid2 and R.uid2 equal to S.uid1. Okay, then I will project R.uid1, R.uid2. So this is the answer. You can read this. Okay, true friends means who follow each other. Let's solve this GATE 2024 question. The relational schema person PID, city describes the city of residence for every person uniquely identified by PID. Means PID identifies this city. Means this functional dependency we have. PID determines city. Okay, this functional dependency we have. You can see, because the question is saying that this relation schema is describing the city in which a person is residing. Okay, so you can see for every person uniquely identified by PID. The following relational algebra operators are available: selection, projection. Okay, selection is available, projection is available, cross product is available, rename is available. Okay, rename that is available. Now, to find the list of cities where at least three people reside using the above operators, the minimum number of cross product operations that must be used. Tell me the answer. For this information, I want this information, the list of cities where at least three people are residing. Now you tell me, how many tuples will give me this information? I want those cities where at least three people are residing. So three tuples will give me this information. Yes or no? I need three tuples for this information. Like basically this person. Okay, here you have PID and city. Remember, three tuples will give me this information. Okay, like this city is same. City is same. Okay, three tuples will give me this information. P1, P2, P3. Now this city I want in the answer. I want those cities where at least three people are residing. Okay, so three tuples can give me this information. I can say three tuples. Okay, three tuples give this info. Remember, one thing I want to tell you, there can be more people who are in this city C. In this city C, there can be more people. Okay, but please tell me, can I say three are enough? Let me know. Can I say three are enough? Yes, three are enough and three are mandatory. I can say three are enough and three are mandatory. Okay, because I want those city where at least three people are residing. Okay, so I can say three tuples are enough where you have city C, city C, city C. Okay, so three tuples are enough and three tuples are mandatory. Okay, so finally I can say that three tuples will give you this information. There can be more tuples, there can be more people in the city C. That is fine, but three tuples are enough and three tuples are mandatory. Okay, so three tuples will give you this information. Means I need what? I need three copies of table person. Yes or no? I need three copies of table person. Simple, very simple. Now, what is the idea? From the idea, you can easily see. Basically, I need three copies of table person. This, okay, table T1 I need, table T2 I need, and table T3 I need. Okay, and in this cross product, I need those tuples where what should happen? Tell me. In this cross product, remember, the city must be same. It is like this. See, in this T1, there are two things. One is person, comma, city. In T2, there is person, comma, city. Here also person, comma, city. Okay. So in this cross product, I am looking for this type of tuple. In this tuple, what should happen? City must be same. For example, let's assume city Rajasthan, or maybe city, let's assume city is some Goa. Okay. Now remember, city must be same. And what should happen? The people must be different. Okay, this is the idea, that these three things, this must be same as this must be same as this, and what should happen? The person must be different. This P1, this P2, this P3. Okay, so this P1 must be different from this P2. This P2 must be different from this P3, and this P1 must be different from this P3. Okay, so finally tell me, how many cross product are needed? Only two cross product are needed. Is this clear? Remember, I need three copies of table person. Okay, for this table, this is your table. For this table, I need three copies. Okay, remember, I need three copies of table person. Okay, but remember, only two cross products are needed. Yes or no? Is this clear? So the answer for this question, that will be only two cross product are needed. Is this clear? Please tell me. Very simple question. I want those cities where at least three people are residing. Then tell me, this is the idea, this is the overall idea. So let me write the query. The query is like this, remember. First, I will create 3 copies of person table. Okay, I will rename, remember this person table, I will rename T1. Okay, I will do the cross product, this person table. Okay, we have a person table. I will rename T2. Basically, I am creating 3 copies of person table. We already have this person table. In this person table, we have PID, person ID, comma city. Okay, so very simple. Now you can see I am creating 3 copies of this person table, cross product, rename. This is the rename operator. Okay, correct. This is the rename operator. I am renaming. You can see I am creating 3 copies of this person table. Now, once this is done, okay, in this, what I will do, I will select those tuples. Which tuples I will select? I will select those tuples where what should happen? Their city must be same. Yes or no? Their city must be same. Means T1 dot city should be equal to T2 dot city. Okay, and and T2 dot city should be equal to T3 dot city. And what should happen? So their city must be same, but their person must be different. Means T1 dot PID must be different from T2 dot PID, and T2 dot PID must be different from T3 dot PID, and T1 dot PID must be different from T3 dot PID. Okay, very simple. And finally, what I will do, I will project in this entire thing. I will project what? I will project the city. Yes or no? I will project the city. Means okay, any one city means T1 dot city. This is what I will project. Is this clear? I will project T1 dot city. So this is the answer. Now in this answer, how many cross product are needed? Please tell me. How many cross product? 3 cross product. Very simple. Yes or no? Sorry, 2 cross product. Okay, I need 3 copies of this table person. For this table person, I need 3 copies, and I only need 2 cross product. This will be the selection condition. This will be the projection. So for this question, answer is option B. Let me tell you what was the common mistake in this question, in this GATE 2024 question. What was the silly mistake? Can anyone tell me? What was the silly mistake? And this silly mistake many students made. A lot of students made this silly mistake. See, students were thinking that, yes, I need 3 copies of table person. So it means I need 3 cross product. Okay, see, this was a silly mistake. This was a silly mistake, and many toppers, they made this silly mistake. This was the silly mistake because students were thinking that, okay, I need 3 copies of this table person. For this table person, I need 3 copies. Okay, one copy, another copy, another copy. It means I need 3 cross product. But if you have 3 copies, then 2 cross product will be needed. Yes or no? Do you agree with me? Okay, so in this question, they are asking how many cross product are needed. I hope this point is clear. So the answer will be option B. Let's move on now. Now let's see derived operators. We have already seen the basic operators. Okay, what are the basic operators in the relational algebra? These are the basic operators. There are 6 basic operators. Selection, this is used for selecting the tuples. Okay, this is used to filter the tuples. Projection, this is used to filter the columns. Cartesian product, every tuple combined with every tuple. Okay, this is called cross product, or you can call it cross join. Set difference, this is a set operation, means all the tuples of the first table which are not in the table 2. Okay, union, you are doing the union of the tables and renaming. Okay, we are renaming the attributes and the relation. So these are the 6 basic operations. We have already seen all of them. We have done the complete analysis of all of them. Okay, now we need to see some derived operators. Means from these basic operators, from these 6 basic operators, we can derive these operations. Like we can derive intersection, natural join, conditional join, and division. Okay, so these are the additional operators. Remember, these additional operators, they are derived, means all of them you can derive from the basic operators. So these derived operators, they do not give you any extra power. Okay, for example, this natural join, what you can do with natural join, you can also do with the basic operators. So this natural join does not give you extra power. What you can do with the division operation, you can also do with the basic operations. So this division does not give you extra power. So remember, these operators, these derived operators, they do not give you any extra power. Okay, any extra expressive power. Very simple. So let's see what are these derived operators. First, we will see the join operations. These are the derived operations. Okay, let's see the join operations. So first of all, let me tell you, in relational algebra, join means inner join. This join, you can also call it inner join. So by default, join means inner join. Is this clear? We will also see what is outer join. Okay, but by default, join means inner join. Okay. Now, what are the inner join operations? So this inner, remember, this is, I can say you can hide it, no problem. Because by default, join means inner join. Okay, so how many inner join operations we have? So there are three inner join operations. One is conditional join. One is conditional join. Another name for the same, this is theta join. Okay, this is another name for the same operation, conditional join, or you can call it theta join. Remember, inner is hidden, yes or no? Means you can call it theta inner join. You can call it conditional inner join, because by default, join means inner join. Okay, so conditional join, that simply means conditional inner join. Theta join means theta inner join. Okay, so this is your conditional join. And what is the symbol for this? The symbol for this is, you can see this type of symbol is used. Okay, and there is a condition, so you can write it C, or you can write this condition as theta. Okay, or the symbol is this, that this condition you can call it theta. So either you can call it conditional join or you can call it theta join. They are same. You can write C. C means condition. Theta also means condition. Okay, so there is a condition. So this is the symbol. Okay, another is, there is a special case of conditional join, that is equijoin. I can call it 1.1. Okay, that is equijoin. Equijoin. We will see. This is a special case of conditional join. And another is natural join. Natural join. Okay, or you can call it natural inner join, because by default join means inner join. So natural join. And remember the symbol is that's it. This is the symbol. Okay, very simple. Now, so what we call this symbol, this is the natural join symbol. And remember, this is the conditional join symbol. Okay, have you seen this symbol somewhere? This symbol, have you seen somewhere? This is like, I think bow tie, yes or no? You know, here on tie, there is this type of, maybe you have seen in some movies. Okay, here, what do we call it? Okay, this is top part of the tie, right? Okay, so this type of symbol, maybe you have seen this. Anyway, so these are the join operations. So remember, we need to study conditional join, we need to study equijoin, and we need to study natural join. And remember, join means inner join. So all of them are inner join operations. Okay, now let's move on. So this is the idea. Join means inner join. Both are same. So you can say theta join or you can say theta inner join. Both are fine. Equi join or you can say equi inner join. Natural join or you can say natural inner join, because join means inner join. All of them are inner join operations. Okay. So first let's see what is conditional inner join, or I can say conditional join. Okay. You can hide this conditional join, or I can say theta join. So what is this? Let me tell you the syntax. The syntax is like this, that you have some R, you have some S. Okay, these are the tables, and this symbol. Okay, so this symbol and followed by some condition. Here you write a condition. Okay, this is the syntax. Very simple. Okay, or this condition, basically you can, this condition you can denote by theta. Both are fine. Both are fine. Basically here this theta means there's a condition basically. Okay, there is a condition. This is basically tuple selection condition. This is tuple selection condition. Okay, this theta. Similarly, this C, this is a tuple selection condition. Okay. Now let me tell you, whenever you see this, this is equivalent to what? This is equivalent to you are doing the cross product of r comma s, and then you are selecting these tuples based on this tuple selection condition. Okay, is this clear? So remember, this is equivalent to you are doing r cross s, and then you are selecting the tuples based on this condition, because you already know that this is this theta. Remember, this is tuple selection condition. Okay, so like this, is this clear? Very simple. So first you do the cross product, and then you are selecting the tuples based on this condition. But one thing I want to tell you, see, they are equivalent, means this and this, they are equivalent. But will you do cross product? Will you do cross product? Don't do cross product. For example, let's assume here you have 5 tuples, here you have 6 tuples. Then if you do cross product, there will be 30 tuples. Yes or no? 30 tuples. So you don't have to do this cross product. You can basically directly do this. Means you look at R, you look at S, and you match those tuples where this condition is satisfied. Okay, so again, I'm telling you. So this is the idea that R, this conditional join CS. So here, this is equivalent to R cross S. First you do R cross S, then you select those tuples where condition C is satisfied. This is fine, but this is not how you will evaluate. Okay, the evaluation will be like this. Okay, don't do cross product. There is no need to do cross product. Basically, this R and this conditional join and this S. So remember, the evaluation will be like this. Those tuples of R will match with tuples of S where conditioning is satisfied. Means tuples of R, I can say tuples of R will match with those tuples of S, those tuples of S such that condition C is satisfied. Condition C is satisfied by the matching. Okay, by the matching. Is this clear? Or I can say that such that condition C is satisfied. That's it. So very simple. If you see this query, then remember, tuples of R will match with those tuples of S where such that condition is satisfied. This condition C is satisfied. Okay. Now, very simple. So you can see this is the idea. Okay, and the symbol, let me tell you the symbol. The symbol is R, this join, and this is the condition S. This is the symbol. Okay, and this is equivalent to this. Means this expression and this expression, they are same. They are equivalent. Okay, so first you are basically doing the cross product. You can see you are doing the cross product. Then you are applying the tuple selection condition. This C is tuple selection condition. This C is tuple selection condition. So very simple. Okay. So first you are doing the cross product, then you are selecting the tuples. Now let's see this. Let's see this example. So you can see that we want this query. See, in this query, you can see the condition is B less than D. Yes or no? So tell me how to evaluate this. Will you do the cross product? Please tell me, will you do the cross product? In the cross product, there will be 6 tuples in the cross product. If you do R cross S, 6 tuples will be there. Then you will apply this condition. Don't do that. Do not do that. Okay. What you can easily do here, basically, tuples of R will match with the tuples of S where this condition will be satisfied. That's it. So remember this condition. This is your theta. You can call it theta. This is your theta. Or you can call it, this is your condition C. This is your condition. Tuple selection condition. Okay. You can call it theta also. So basically, this is your theta join. You can call it theta join, or you can call it conditional join. Both are fine, both are same. Okay, actually this is latest word and this is old word. In the old times, this word was used. Okay, nowadays this word is used, but both are fine, both are same. Okay, so very simple. Now you tell me how to calculate this R theta join S, and this is the condition B is less than D. B should be less than D. Okay, very simple. This should be less than D. Okay, less than. Now tell me, this tuple will match with this which tuple? Remember, tuples of R will match with tuples of S where this condition will be satisfied. B should be less than D. B should be less than D. So this tuple will match with this one also, this one also. Do you agree? Okay, so you can easily see 1, 2, 3, 3, 1. 1, 2, 3, 3, 1, you can see here. 1, 2, 3, 3, 1. 1, 2, 3, 6, 2. You can see here. 1, 2, 3, 6, 2. Okay, what else? Please tell me what else. What about this tuple? This tuple will match with those tuples where this condition will be satisfied. B should be less than D. Okay, so here you can see this tuple will match with B should be less than D. B, this should be less than D. So yes, this will only match with this. Okay, because you can see 5 is less than 6, but 5 is not less than 3. And this tuple will not match with anyone. Okay, so finally you can see 4, 5, 6, 6, 2. You can see 4, 5, 6, 6, 2. Is this clear? Please tell me. And you can see this is the schema. So very simple. The idea is very simple. You can see the same answer you will get for which query? The same answer you will get for which query? If you do R cross S, first you do R cross S, and then you select tuples where B is less than D. Okay, correct? So the same query will, this query will also give you the same output. You can check. Anyway, let's move on now. So this is very simple. Now let me tell you one more thing. In these two tables, which tuples are not matching with anyone? Please tell me. In these two tables, which tuple is not matching with anyone? Which tuple is not matching with anyone? This tuple, right? Okay, this is 7, 8, 9. This tuple is not matching with anyone. So this is called dangling tuple. This is called dangling tuple because this is not matching with anyone. Dangling tuple means not matching with anyone. Not matching with anyone. Okay, so this tuple is called dangling tuple. Okay, remember here, this is not a dangling tuple because this is matching with someone. This is also matching with someone. So only this is the dangling tuple, this 7, 8, 9, because this is not matching with anyone. So this is dangling tuple. Very simple. Now let's move on. Now let me tell you one more thing. Let's assume you have a relation R where you have A comma B, and let's assume you have a relation S where you have B comma C. Now tell me, what will be the schema? You tell me about the schema of R, this conditional join, this conditional join. Okay, conditional join S. Tell me what will be the schema of this? What will be the schema? Now you already know that this is actually equivalent to R cross S. You are doing the cross product. So the schema of cross product will be used. Yes or no? Is this clear? Schema of the cross product will be used. So schema of this join operation will be same as schema of R cross S. Okay, schema will be same because anyway you can see that this is equivalent to this. So schema of R cross S. So finally you can see that the schema of this query theta S, the schema of this query will be like this. Okay, there will be A. You can see B is common. Yes or no? This B is common. So you can write it R dot B, S dot B, C. Okay, so like this. This will be the schema. Is this clear? Please tell me. Let me know. So like this you can easily do. Okay, because this is the common name. So you can write it R dot B, S dot B. Now let's move on. So we have seen what is this conditional join, or you can call it theta join. What is a dangling tuple? We have already seen a tuple that fails to pair with any tuple of the other table. A tuple that is failing to match with any tuple of the other table, that is called dangling tuple. This we have seen. Now let's move on. Now let's see this. This is table U, this is table V. Okay, now what is this? Tell me. This one. This is your conditional join. Yes or no? This is our conditional join. Very simple. This is the conditional join. Conditional join. So here what will happen? In this conditional join, what will happen? Very simple. Tuples of U will match with those tuples of V where this condition will be satisfied. A should be less than D. This A, this should be less than D. Okay, so tell me, this first tuple will match with whom? This first tuple, it will match with whom? A should be less than D. Okay, so you can see 1 is less than 4, 1 is less than 5, 1 is less than 10. So this first tuple will match with all of them. You can see the answer. Okay, in the answer you can see A, U dot B, U dot C, because they have common name BC, BC. Please understand. Here you have BC, here you have BC. So you can see here U dot BC, U dot B, U dot C, V dot B, V dot C. Okay. Anyway, you can see 1, 2, 3 will pair with 2, 3, 4. 1, 2, 3, 2, 3, 4. Next, 1, 2, 3 will pair with 2, 3, 5. 1, 2, 3, 2, 3, 5. Next, 1, 2, 3 will pair with 7, 8, 10. 1, 2, 3, 7, 8, 10. Okay, so you can see this tuple is pairing with everyone. What about this next tuple? This will pair with whom? Remember, condition is A less than D. So 6 is less than whom? You can see that 6. This is less than D. So 6 is only less than 10. So this will pair with this one. Okay, yes or no? You can see that 6, 7, 8, 7, 8, 10. 6, 7, 8, 7, 8, 10. So you are getting this. Next, this will pair with whom? 7, 9, 7, 8. So 9 should be less than D. So you can see this will pair with the last one. Correct? This will pair with the last one. You can see because A is less than D. 9 is less than 10. So you can see 9, 7, 8, 7, 8, 10. 9, 7, 8, 7, 8, 10. Okay, very simple. Tell me what are the dangling tuples here? You let me know what are the dangling tuples. Please tell me what are the dangling tuples? There is no dangling tuple. Yes or no? There is none. Okay, because you can see there is no tuple which is not pairing with anyone. You can see there is no dangling tuple here. Okay, there is no tuple which is not pairing with anyone. So very simple, dangling tuple is none. Now, let's see the answer for this query. Tell me how many tuples will be there in the answer. S1, this is conditional join. You can see this is the condition that S1 dot SID is less than R1 dot SID. Okay, so this is your table S1, this is your table R1. You tell me how many tuples in the output. Tell me number of tuples in output. What will be the answer? So very easily you can see that this is the condition. Okay, so remember those tuples of S1 will pair with those tuples of R1 where this condition will be satisfied. So you can see this SID should be less than this SID. Okay, I can say this SID should be less than this SID. So finally you can see 22 is less than 58. So these two tuples will pair. Yes or no? This first tuple and this second tuple, they will match, they will pair. Next, you can see this 31 is less than 58. So this will pair. This will not pair with anyone. So tell me how many dangling tuples are there? What is the number of dangling tuples? Number of dangling tuples, what is that? So number of dangling tuples is this is a dangling tuple and this is a dangling tuple. So two dangling tuples are there. Okay, and how many tuples in the output? That will be 2. Yes or no? So 2 tuples in the output and number of dangling tuples is also 2. So very simple. You can easily see these are the 2 tuples in the output. And I can say that these are the dangling tuples. I can say this is a dangling tuple and this is a dangling tuple. These two are dangling tuples. So two dangling tuples are there. Okay, let's move on. So we have seen what is theta join. Tell me the answer for this question. Can I give this question as a homework or let's solve it? Let me quickly know what is the answer. So you can see here you have AB, here you have BCD. These are the two tables. There is theta join and this is given to you that we are doing theta join. Remember, we are doing RS theta join. This theta join we are doing. And what is the condition? The condition is given to you that is that R dot A should be less than S dot C and there is and here R dot B should be less than S dot D. Okay, so this is the theta. This is the theta. So very simple. So remember, this whole condition is your theta. Now tell me. So this will pair with which tuple of S? Let me know. Remember, tuples of R will pair with tuples of S where condition is satisfied, where this condition should be satisfied. So tell me about this tuple 1, 2. These two conditions you have to check that R dot A should be less than S dot C, and R dot B should be less than S dot D. It is like this AB should be less than CD. Yes or no? Okay, you can say that this is like that AB should be less than this RAB. This RAB should be less than SCD. Okay, yes or no? So like this you can understand that this must be less than this one. Okay, is this clear? 1 2 is less than 4 6. Yes, that is correct. Okay, so you can easily see that this will pair with this one. Okay, 1 2 will pair with 6 8 also. This will also pair with this one. Correct? So you can see the question is asking identify which one belongs to this query. Okay, in the output of this query, which tuple will be there? So you can see 1 2 2 4 6 will be there. So this will be there 1 2 2 4 6. Yes or no? 1 2 2 4 6. This will be there. Next 1 2 4 6 8. That will be there. Next, so 1 2 2 4 6 will be there. 1 2 2 6 8. Will it be there? 1 2 2. No, this will not be there. Yes or no? This will not be there. What about this tuple? This will pair with whom? Please tell me. This 3 4. This will pair with, remember 3 4 should be less than 4 6. Yes, that is correct. Okay, means you can see RA should be less than SC and RB should be less than SD. So 3 4 less than, this is correct. Okay, this will, you can see 3 4 will pair with this tuple, also this tuple. Okay, so you can see 3 4 4 6 8. 3 4 4 6 8. That is correct. That is correct. What about 3 4 5 7 9? No, this is not correct. Okay, what about this 5 6? This will pair with whom? Let me know. This tuple will pair with 5 6 should be less than CD. Okay, so you can see 5 6. This will pair with this one, and this will pair with this one. Okay, very simple. I hope this point is clear. So tell me, how many tuples in the output? What is the number of tuples in output? Let me know. How many tuples will be there in the output? So very simple. This tuple is matching with everyone. So 3 tuple because of this. This is matching with everyone. So 3 because of this. So the answer is like 3 plus 3 plus 2. Answer is 8. Okay. 8 tuples in the output. And there is no dangling tuple. Yes or no? And there is no dangling tuple. Simple. Let's move on now. Now let's see equijoin. What is this concept? This is a conditional join with equality condition. That's it. Nothing else. Okay, I told you that equijoin, this is a special case of conditional join. This equijoin, what is this? This is just a special case. This is just a special case of conditional join. Okay. In this equijoin, what happens? That we only use comparison equality. Okay. Only equality comparison is used. Only equality comparison is used. Is used. Okay. Means we can't use, okay, in this equijoin, we can't use less than, greater than, equal to, less than, equal to, greater than. Okay, so like this, these things we cannot use. So very simple. So this is just a special case of conditional join where only this equality comparison is used, nothing else. Okay, there is nothing fancy here. Okay, equijoin, this is basically same as conditional join. When you are solving any question of equijoin, then you are basically solving question of conditional join. There is nothing fancy here. This is the only thing that we use equality. We don't use these things. Okay, if you are only using this, then you can call it equijoin. Otherwise, you can call it conditional join. Remember, every equijoin is also conditional join. Okay, so this is the idea that you can see this is your conditional join. If C involves only this comparison operator, then we are calling it equijoin. Okay, so this is the definition. You can see. Okay, the condition is equality. That's it. This is the condition. You are using the equality condition. Let's move on. Let's see this one. Tell me, this is conditional join or not? Let me know. Look at this and tell me, is this conditional join? Yes, this is conditional join. Is this equijoin? Yes, this is equijoin. Okay, what we are doing here, you can see R is as it is. Next, we are renaming. This is renaming. Yes or no? This is called renaming. This is renaming operation. Okay, so this table S we are renaming as SCD. Okay, basically we are renaming the attributes. Yes or no? We are renaming operation for attributes. For attributes of S. You can see attributes of S. We are renaming them. Okay, means this table, this will become like this. S, and there will be two attributes. One will be SC, another will be D. Okay, 6, 8, 10, 12. That's it. Okay, very simple. Now finally, we are doing the conditional join. And because the condition is equality, so you can call it, remember, you can call it conditional join, that is correct. If you call it conditional join, that is also correct. If you call it equi join, that is also correct. Okay. So finally, you can see how many columns will be there? Three columns, two columns. So there will be total five columns. You can see. Okay. And because of this condition, C should be equal to SC. So you can see this will match with this one. These two will match. Okay. And you can see this will be dangling tuple, this will be dangling tuple. So there will be two dangling tuples. Okay. Simple. Let's move on now. Now let's solve this question quickly. Tell me the answer for this one. You can see T1 eq join because there is equality condition. We are using equality condition. So this is eq join. T1 eq join T3. Okay, so you can just remove T2. We don't care about T2. Okay, so tell me here, how many tuples in the output? First of all, what is the schema? Let me know what is the schema. T1, there is eq join. There is eq join. T1 dot C should be equal to T3 dot C, T3. Okay, so what will be the schema first? Let me know. The schema will be like this. PRC ABC. So it will be like this. PR T1 dot C, A B T2 dot C. Sorry, T3 dot C. Correct? Okay, so this will be the schema. Very simple. Now you tell me. Very simple. Tuples of T1 will match with those tuples of T3 where this condition will be satisfied. That this T1 dot C, this should be equal to this T3 dot C. They should be equal. So you can see this will pair with whom? This first tuple of T1. This will pair with no one. Yes or no? What about this? This will pair with no one. What about this? This will pair with this tuple also, and this will pair with this tuple also. Next, this will pair with no one. And finally, you can see this will pair with whom? This will pair with this tuple also, and this will pair with this tuple also. So remember, there will be four tuples. Yes or no? Do you agree with me? Like, for example, this type of tuple you will have 25A6, 25A6, 10B6. Okay, this tuple will be there. 25A6, 25, 6, 25C6. Okay, like this. There will be total four tuples. For example, another tuple will be 10B6. Okay, 10B6, 10B6. Okay, here 10B6, 25C6. Okay, so very simple. Is this clear to everyone? And how many dangling tuples? This is dangling, dangling. Okay, so let me write it here. Like this is dangling tuple, dangling tuple. Okay, another dangling tuple. So this D, this means dangling. Okay, this is dangling. And another dangling tuple is this. This is dangling. So there are four dangling tuples. Okay, so let's move on. Can I give this question as a homework? T1 dot P, again eq join because equality condition. This P should be equal to this A. Can I give this question as a homework? How many tuples will be there and how many dangling tuples are there? Okay, remember this should be equal to this. So how many tuples will be there and how many dangling tuples are there? You can call it eq join because there is equality. So you can call it eq join. Anyway, this is basically your conditional join, or I can say theta join. Now let's see the next operation, that is natural join. And this is the definition of natural join: equality of all common attributes. Okay, equality of all common attributes means all attributes with the same name, their equality, you will use as a matching condition. So in the natural join, the matching will happen by equality of all common attributes, all attributes with the common name, with the same name, their equality is your matching condition. Very simple. Okay, so for this natural join, actually this is very important. Natural join, this is actually very important, let me tell you. Okay, so in this natural join, do we give any condition? Do we give any condition? No, there is no condition given. Remember that's it. This is the symbol. No condition is specified. Please understand. Here, no condition is specified. Okay, so these are the things here. First of all, no condition is specified. We do not specify any condition. No condition is specified. Implicitly, what is the condition? Implicitly, what is the condition? Always. Implicitly, condition is what? What is the condition? Please tell me. Because we do not specify any condition. You will not write any condition. See here. Okay, we do not specify any condition. Implicitly, there is fixed condition. What is that? That is equality of all common attributes. Equality of all common attributes. Common attributes means attributes with the same name. Okay, all common attributes. So this is the implicit condition. Very simple. And one more important thing, result will not have any duplicate column. Result will not have redundant column. Redundant columns. Okay, this result will not have redundant columns. Okay, so let me tell you what that means. What that means. See, look at this table R and this table S. So here, what is the common attribute? Please tell me. What is the common attribute? Here the common attribute is B. This is the common attribute. Okay, so in the natural join, what we do? In the natural join, this is your natural join. In the natural join, remember, we check the equality of common attributes. Yes or no? So remember, this tuple will match with whom? This first tuple will match with whom? We check the equality of common attributes. Their equality we will check. Equality of all the common attributes. This is the common attribute B. So this tuple will match with whom? This tuple will match with this tuple only. That's it. And what about the next? For example, this tuple will match with whom? This will not match with, sorry, this will actually match with this. Yes or no? Is this clear? So that's it. So remember, in this, we do not write redundant columns. The result will not have redundant columns. Okay, means this column B, we will write only one time. So the schema will be A, B, C, D. Okay, we write only one time. We don't write this B two times. Okay, this B, B. We do not write two times. Only one time we write. Okay, yes or no? One time, one copy. Only one copy is taken in the output. Simple. Okay, so the answer will have only two tuples. That will be, this tuple will match with this tuple. I can say this tuple will pair with this tuple. So that will be 1, 2, 5, 6. And the next will be 3, 4, 7, 8. So this will be your answer. And what are dangling tuples? Please tell me. Here, this is the dangling tuple. Correct? Okay, I can say this is your dangling tuple. Because this is not pairing with anyone. So this is your dangling tuple. This is not matching with anyone. So this is dangling tuple. Is this clear? Please tell me, did you understand what is natural join? Okay. One more thing I want to ask. I want to ask, if I give you this one, consider this R, okay, and this join S, and here I'm writing that R dot B should be equal to S dot B. Is this natural join? What is the difference between this query and natural join? What are the difference between these two? Or are they same? Are they same or are they different? Please tell me. Are they same or are they different? Same or different? These two queries. Please tell me. Are they same or are they different? They are different. There is a small difference. What is that? There is a small difference. I told you that in the natural join, no condition is specified. I told you no condition is specified. Implicit condition is there. That is equality of all common attributes. And remember, result will not have redundant columns. This is natural join. Okay. So let me tell you the small difference. When you do this, you are specifying the condition. This is becoming conditional join. Are you getting my point? Now this has become conditional join. Now this has become your conditional join. Is this clear? So the output will have A, then there will be R dot B, there will be S dot B, then there will be C, there will be D. Okay, is this clear? So this redundant column will be there. You can see the answer will be 1, 2, 2, 5, 6. Another will be 3, 4, 4, 7, 8. Now, did you understand that you have a redundant column? Did you see redundant column? 2, 4, 2, 4. Redundant column. Yes or no? Redundant column. Okay, is this clear? So remember, they are actually different. They are not same. They are actually different. Okay, because here there will be no redundant column. Here there is no redundant column. I hope this point is clear. So very simple. Remember, in the natural join, we don't specify any condition. The condition is always implicit. Okay, the condition is implicit. That is equality of all common attributes. And result will not have any redundant columns. Simple, right? Okay. Now let's move on. Now let's see this. This is your natural join. No condition is specified. That's it. There is no condition is specified. So what is the condition then? Implicitly, what is the condition? Implicitly, you can see the equality of all common attributes. Okay, means this BC, this should be same as this BC. Okay, is this clear? I can say that this table, this UBC, remember, must be equal to VBC. This is implicit condition. Okay, this is the implicit condition. Means they must be same because all common attributes, they must be equal. Okay, equality of all common attributes. Natural join, equality of all common attributes. So these are the common attributes BC. So tell me, this will pair with whom? Here you can see BC value is 2, 3. So this will pair with this tuple will pair with whom? Let me know. This tuple will pair with BC here 2, 3, here BC 2, 3. Okay, so you can see this will pair with these two tuples. So there will be, you can see 1, 2, 3, 4, 1, 2, 3, 5. Okay, yes or no? You can see we do not write any redundant columns. So you can see A, B, C, D. We do not write this BC 2 times. We don't do that. Okay, in the natural join, in the result, we don't have any redundant columns. What about this next one? Here you can see BC value is 7, 8. Okay, so you can see this will match with this one. Okay, correct. What about next? What about next? You can see this will match with this one. Okay, you can see 7, 8, 7, 8. So that's it. So finally, 4 tuples will be there. And is there any dangling tuple? Is there any dangling tuple? There is no dangling tuple. Yes or no? Here you can see there is no dangling tuple. Okay, so very easily you can understand this natural join. So in this natural join, we equate attributes of the same name. Okay, all the attributes of the same name, we equate them. We check their equality. Okay, we project only one copy of each equated attribute. Okay, basically we remove the redundant columns. This is the symbol. We don't specify any condition. There is implicit condition here. Okay, now let's move on. Now, if there is no common attribute, then what will happen? Like my question is, let's assume you have R, here you have AB, and you have S, here you have CD. Now you tell me what will be the result of R natural join S, because there is no common attribute. We have no common attribute, yes or no? So what will be the result? What should be the result? We cannot check equality of common attribute because there is no common attribute. So we cannot check equality of common attribute. Okay, in this situation, what will be the natural join? That will be same as cross product. Okay, in this situation, the answer will be simply cross product. Okay, is this clear? Because there is no common attribute, so we have no way of checking the equality of common attribute. Okay, yes or no? Actually, let me tell you one more thing. One more thing, let me tell you. See, can you write natural join in terms of, can you write natural join in terms of basic operations? Natural join in terms of basic operations. Can you write in terms of basic operations? Let me know. For example, let's assume R has AB. Okay, maybe R has ABC and S has BCD. Now you tell me how to write R natural join S in terms of basic operations. How you will write? Let me know. Very simple. First you will do the cross product, right? Okay, yes or no? First you will do the cross product, then you will selection condition. In the natural join, what is the selection condition? In the natural join, the selection condition is equality of common attributes. So what you will do? Very simple. R dot B should be equal to S dot B and R dot C should be equal to S dot C. Equality of common attributes. Correct. After this, what you will project? Let me know. What you will project? Please tell me. What are you going to project? You will project only unique attributes. Okay, yes or no? You will project A, you will project R dot B, you will project R dot C, and you will project D. Okay, basically, you will project only unique attributes. Projecting unique attributes. Did you understand? Please tell me. Let me know. Now you tell me, if there is no common attribute, then what will happen? Then there is no selection condition. Do you agree with me? If there is no common attribute, there is no selection condition. Are you getting my point? See, this is the natural join in terms of basic operations. What we do? Basically, we do the cross product, then we check the equality of all common attributes, then we project unique attributes. This is how you can write natural join in terms of basic operations. Now you tell me, very simple question. If there is no common attribute, then how to write? What will be this natural join? Very simple. You already know. First, you will do the cross product. Now there is no selection condition. Yes or no? Do you agree? There is no selection condition. There is no condition to select. So all the tuples will be selected. There is no condition here. Agree? There is no condition here. And then you will find unique attributes. Unique attributes means A, B, C, D. So is this same as R cross S? Can you notice this whole thing? This is same as R cross S because there is no filter condition. There is no tuple selection condition. So all the tuples will pass. There is no tuple selection condition. So all tuples will pass. There is no condition to filter tuples. So all tuples will pass. So you can see if there is no common attribute, then your result is same as R cross S. I hope you understood. Okay, so this is the note. Natural join if no common attribute. If there is no common attribute, then result will be same as cross product of two relations. Okay. Okay. Let's do this question. Is this natural join? Tell me. Is this natural join? No. This is a conditional join. Yes or no? This is your theta join. So tell me how many tuples in the output? Let me know. In the output, how many tuples? I'm asking number of tuples in the output. Number of tuples in output and number of dangling tuples. So let me know. Very simple. You can see tuples of U will pair with those tuples of V where this condition is satisfied. So A should be less than D. This A, this should be less than D. We should check that they are, okay, this is less than D. Next, you can see UB is not equal to VB. This and this, they are not equal. Okay, this and this, they are not equal. So finally, here your answer will be what? Answer will be A, U dot B, schema will be U dot B, then U dot C, then V dot B, then V dot C, and then D. This will be the schema, first of all. Okay, very simple. This is your theta join, conditional join. So schema will be this. Now you know This is the schema. Now tell me, which tuple will match with which tuple? Tell me the first tuple. This will pair with whom? This first tuple will pair with whom? Remember, A should be less than D. So 1 should be less than D. This condition is satisfied. Next, you can see this B should not be equal to VB. Okay, so I can say that this tuple will match with only this tuple. Yes or no? Correct? This tuple will match with this tuple. So here you will have, I can say 1, 2, 3, 7, 8, 10. This is what you will get. This is one of the tuples. Another tuple, tell me. You can see another tuple. A should be less than D. So 6 should be less than 10. Okay, 6 should be less than 10. And you can see B is not equal to B. B value should not be equal. So you can see this is dangling tuple. What about this one? What about this one? Here you can see that A should be less than D and B value should be not equal. So that's it. Only one tuple in the output. Do you agree? Only one tuple in the output. Yes or no? So number of tuples in output, that will be 1. In output, that is 1. And how many dangling tuples? How many dangling tuples? You can see this is dangling, this is dangling. They are not pairing with anyone. They are not pairing with anyone. So 4 dangling tuples. 2 dangling tuples in R. Sorry, 2 dangling tuples in U. 2 dangling tuples in V. Okay, so you can see only one tuple in the output. Let's move on. Now we will study outer join. We have seen join operation. By default, join operation means inner join. Now we will study outer join. Okay, what is this concept? Before we study this concept outer join, I want to tell you one more thing. That is, this is not an operation of basic relational algebra. This is not a part of classical relational algebra. So let me tell you, outer join is not considered. This is not considered part of classical relational algebra. I told you in the relational algebra, we don't have concept of null. Yes or no? Do you remember I told you in the part 1 that relational algebra has no concept of null values. Okay. But in the outer join, we will use null values. In the outer join, we will use null values. So actually this outer join, this is not part of classical relational algebra. I can say this outer join, this is an extended operation of relational algebra. Okay, so let me tell you, outer join, this is a extended, this is part of extended relational algebra. This is part of, not part of classical algebra. This is part of extended relational algebra. Relational algebra. Okay, this is not part of basic, or I can say classical relational algebra, because in the classical relational algebra there is no concept of null values. Okay, and one more thing, because we are using null values, and in the classical relational algebra there is no null values. See, the basic operations, selection, projection, cross product, set union, set difference, and rename, is there any concept null? Those operations, can they handle null value? Please tell me, those operations, can they introduce null values? No, they cannot. Yes or no? So in the outer join, we have null values. So it means this outer join, is it improving the expressive power? This outer join, does it improve? Does it increase the power of relational algebra? Please tell me. Does it give you more power in the relational algebra? This outer join, does it give you more power in the relational algebra? Yes, because this can handle null values, or I can say this can introduce null values. So these operations enhance the expressive power of relational algebra. Original relational algebra does not have outer join. You can easily see here, like this is the screenshot from Ullmann book. Okay, you can see in the Ullmann book, you can see these are the extended operators of relational algebra. There are many extended operators. These extended operators, they increase the expressive power. They increase expressive power of expressive power. They increase the power of relational algebra. Okay, they increase the expressive power of relational algebra. There are many, but in our gate syllabus, we only have outer join. Actually, there are many. For example, duplicate elimination, aggregation, grouping operator. Okay, there is projection operator, there is sorting operator. Are you getting my point? That they will increase the relational algebra power if you use them. Is this clear? You can see outer join. This is a extended operation of relational algebra. This is what we have in GATE syllabus. Okay, I hope this point is clear to everyone. So again, I'm telling you that these operations, this outer join operation, this is not part of original relational algebra. Okay, I can say outer join. This is not part of original relational algebra. This is an extended operation, not part of original relational algebra. Okay, this is just a extended, this is part of extended relational algebra. Okay, and they will enhance the expressive power, they will increase the expressive power of relational algebra. Okay, so in the original relational algebra, what we have? Please tell me. In the original, in the original relational algebra, there is no concept of null, that you already know. There is no concept of null. This we have already seen. There is no concept of null values. Okay. Also, you know that these are the operations. Okay. These are the basic operations. Basic operations are selection, projection, cross product, union, set difference, renaming. These are the basic operations. And what are the derived operations? What are the derived operations? The derived operations are intersection, natural join, conditional join, okay, conditional join, and division. We will study division also. Okay, so these are the derived. Okay, remember they are part of original, or I can say relational algebra. Is this clear? Please tell me. And outer join, what is that? In the extended relational algebra, there is outer join. In the extended relational algebra, we have outer join. I hope this point is clear. Okay. So remember, these will not increase the power of relational algebra. Means these derived operators, you can derive them from these. Okay, so these derived operations, they will not increase the power. This natural join, or I can say this division, they do not increase the power of relational algebra. But this outer join, this will increase the power of relational algebra. So this is extended relational algebra. This is not part of original relational algebra. Okay, let's move on now. So let's see what is outer join then. This is actually very simple concept. This is inner join plus dangling tuples with null values. Okay, that is the reason dangling tuples are important. In every example, I told you what are the dangling tuples. Okay, because these are useful in the outer join. So remember, outer join means you do the inner join, then for the dangling tuples, you combine them with null values and you insert. Okay, you insert dangling tuples combined with null values. So this is very simple definition of outer join. Okay. So here remember, this outer join has three type of outer join we have. Okay, we have three type of outer join. One is left outer join. The name itself is telling you, first you do inner join, then you add the dangling tuples of left table with null values. Okay, first you do inner join, then you add dangling tuples of left table. Dangling tuples of left table, you add them with null values. Next, right outer join. First you do inner join, then the dangling tuples of right table, you join them with null values. Full outer join. First you do inner join, then the dangling tuples of both the tables, you join them with null values. Okay, so this is the idea. So there are three type of outer join operation. Is this clear? Very simple, right? Okay. One more thing. This inner join, this can be any inner join. This can be any inner join. This can be conditional join, or this can be either this can be conditional join or this can be natural join. If no condition is given, then by default, which one? If no condition is given, then tell me, then by default, natural join. Okay, by default, natural join. If no condition given. If no condition is given. If there is no condition given, then by default, natural join. Okay, very simple. So I hope all these points are clear. Now, with example, these points will become more clear. So first, let me tell you about outer join. So there are three type of outer join. Okay, let me quickly tell you what are the syntax of outer join. Outer join. Okay, there are three type of outer join. First of all, what are the symbol? Let's see the symbols also. One by one, we will see the symbol. So first, let me tell you about the left outer join. Left outer join. Okay, and the symbol of left outer join is like this. First to do the inner join. First to do the inner join, then the left table dangling tuples you add. Okay, first you do inner join, and then the left table dangling tuples you add. Okay, so this is the symbol for left outer join. Some people use this symbol, some people they use this symbol. Are you getting my point? See, this symbol, but on left if I put, only on left if I put, then that means left outer join. Some people use this symbol. Is this clear? Some people they use, for this left outer join, some people they use this symbol. Okay, that your outer join means O, and L means left outer join. Is this clear? This is most famous, but all these symbols have been used. Is this clear? Please tell me, did you understand the symbol? These are the symbol. So this is most commonly used. And remember, in this what is happening, in this basically like this, and on the left I'm putting means this is left outer join, or this O means outer join, and this L means left. O means outer join, L means left. Okay, so this is your left outer join. Is this clear? So in this left outer join, what we do? If you have this left outer join, this symbol, this is the symbol. Okay, R left outer join S, or you can write it like this, R left outer join S. Okay, so tell me, in this what you will do? Let me know. Very simple. First you will do the outer join. Okay, first you will do the inner join. Is there any condition here? Did I give you any condition? It means you will do the natural join. Do you agree? Did I give you any condition? I did not give you any condition here. So it means this is your natural join. So here what you will do? First you will do, first do natural join. Okay, first do natural join, then what you do? Then add dangling tuples of R. Dangling tuples of R. Okay, using null values. Using null values for columns of S. For remaining columns of S. For remaining columns of S. Okay, for remaining columns of S. So very simple. I hope this point is clear. One by one, let's see the second. What is the right outer join? In this right outer join, what is the symbol? Right outer join. So the symbol is, first to do inner join. Okay, see the symbol is like this. First to do inner join, and then you add the dangling tuples of right table. Okay, right table dangling tuples you add. Okay, another symbol is what? Another symbol is like this. Another symbol, that is, okay, this, and on the right you are putting. It means right outer join. On the right we are putting. Another symbol is what? Another symbol is this symbol. O means outer, R means right. O means outer, R means right. Okay, is this clear? So very simple. So finally I can say that this is your right outer join. This symbol, and then add the dangling tuples of the right table. So right outer join. Here what you will do, tell me. Did I give you any condition here? Any condition did I give you? No, I did not give you. So you will do the natural join. Yes or no? So very simple. First do R natural join S. R natural join S. Then add dangling tuples of right table. Then add dangling tuples of S. Yes or no? Then add dangling tuples of S using null values. Using null values for remaining columns of R. For remaining columns of R. So very simple. This is the idea of right outer join. And finally, what is our last one? That is a full outer join. Okay, the third one, that is a full outer join. Okay, and the symbol of full outer join, let me tell you the symbol. The symbol is like this. First to do join, first to do inner join, then you add dangling tuples of the left table, then you add dangling tuples of the right table. Okay, in any order. So first you do, remember it is like this. First to do join, add dangling tuples of right table also, add dangling tuples of left table also. So this is the symbol for full outer join. Another symbol is this. That okay, another symbol is this. This is your full outer join. Another symbol. Actually, for full outer join, they will not use this symbol because you will confuse between cross product and this symbol. Okay, so they will mention it. Don't worry about this. Okay, so don't use this. Okay, or they will use this symbol. Means they will use this symbol and they will write O here. This is your full outer join. Okay, they will write here. So outer join, okay, by default outer join means full outer join. Yes or no? By default, outer join means full outer join. By default, when I say outer join, then it's by default it means full outer join. Full outer join. Okay, so full outer join, and you know this is the symbol. First to do inner join, add dangling tuples of left table, add dangling tuples of right table. Okay, so this is the idea. So first do natural join. Okay, then add dangling tuples of both table. Add dangling tuples of both table. Okay, so very simple. So this is the idea. Both tables using null values for some columns, for remaining columns. Okay, so this is the idea. Now let's see a lot of examples we are going to see. But before that, one more thing I want to tell you, that is like this. Tell me if I write like this R, and let's assume I use this symbol. Okay, I write O means outer join. O means outer join. And here I put a condition. Now you tell me what this means. Now what this means. Now this simply means this is a, first you will do, this is conditional inner join. Yes or no? It simply means first you do conditional join. First to do conditional join. First to do conditional join. And then because this is outer, O means outer. Okay, because this is outer, then add dangling tuples. Yes or no? Then add dangling tuples. Then add dangling tuples of both tables. Of both tables using null values. Okay. With example, all these points will become very clear. So let's see this example. This is your table U, this is your table V. And tell me what is this symbol? What this symbol means, let me know. This is your full outer join. Yes or no? O means outer join. O means outer join. O stands for outer join. So, or you can use this symbol. O, by default, this means full outer join. So I can say first to do natural join, then add dangling tuples of right table, add dangling tuples of left table. So this is another symbol. So this is your full outer join. Okay, this is the full outer join. I can say this is the U full outer join V. Okay, so what you will do? First you will do inner join. First you will do natural join. Remember. Okay, because there is no condition. There is no condition. So first you will do natural join. Very simple. Okay, so this is the idea that first what you will do? First you do natural join. That means you do U natural join V. Okay, then what you will do? Then add dangling tuples of both tables. Of both tables. Okay, so first of all, let's do the natural join. In the natural join, these are the common attributes. BC, BC. These are the common attributes. So you can see 2, 3, 2, 3. They will match. 2, 3, 2, 3. They will match. Okay, so I can say this tuple will match with this also, with this also. Okay, very simple. So you can see very simple. 1, 2, 3, 10. 1, 2, 3, 11. 1, 2, 3, 10. 1, 2, 3, 11. Okay, so these two tuples you will get. Very simple. Now, this 5, 6, this will not match with anyone. Next, this 8, 9, this will not match with anyone. So, who are the dangling tuples? Who are the dangling tuples? These are the dangling tuples. And this is a dangling tuple. Yes or no? Okay, correct? These are the dangling tuples. So now this is your natural join. Very, very simple. This is the result of natural join. First you have done the natural join, this is the result. Now you will add the dangling tuples. These are the dangling tuples. Okay, is this clear? These are the dangling tuples. You can see, for example, this is dangling tuple 4, 5, 6, 4, 5, 6. Okay, so you will add this. This, this dangling tuple you will add 4, 5, 6. And in the last column, you will put null. This is your null. In the last column, you will put null. Similarly, 7, 8, 9, you will put. In the remaining column, you will put null. In the remaining column, put null. Similarly, this is 6, 7, 12, you will add. Okay, BCD 6, 7, 12. And in the remaining column, you will put a null. So this is your full outer join. From this example, you can easily understand. I hope this is clear to everyone. Okay, let's see the next. What about this? This is again, what is this symbol? Tell me what this symbol is for. Let me know what this symbol is for. This is your right outer join. Yes or no? This is your right outer join. This is the right outer join. And remember, what is this symbol for? This L means left outer join. This is your left outer join. Okay, clear? Yes or no? Because R means right. O means outer. Okay, this symbol they can give. Okay, in the gate exam, they will give you this symbol, which means right outer join. And this symbol, left outer join. Okay, so this symbol means left outer join. And this symbol means right outer join. Okay, is this clear? So remember, this is the result of natural join, right? Correct. Agree? See, this is the result. These two tuples, this is the result of natural join. This is the result. This is the result of natural join. So first you have done the natural join. Now in the left outer join, what we do? In the left outer join, we add the dangling tuples of left table. These are the dangling tuples of left table. You can see. We add dangling tuples of left table. We will only add dangling tuples of the left table. So you can see 4, 5, 6, 7, 8, 9. In the remaining column, we will put null value. So these are the dangling tuples of left. I can say these are the dangling tuples of left table. Of left table. And remember, this is your null value. Here you can see in the right outer join, what we will do? First we will do natural join, then we will add dangling tuples of the right table. This dangling tuple we will add. The dangling tuple of the right table we will add. And you can see in the remaining column, I will put a null value. Okay, so very simple. This is your dangling tuple. This is the dangling tuple of right table. Okay, and remember this is null. So that's it. Now let's move on. Tell me the answer for this question. First of all, what is this symbol? Let me know what is this symbol for. You can see there is a condition here. You can see there is a condition here. And this means outer. This means outer. So tell me actually what this means. So remember, this is same as you are doing full outer join. Yes or no? This is your full outer join. So you will do the full outer join, but first you will do the inner join. Okay, remember, very simple. First do inner join. Inner conditional join. Yes or no? Inner conditional join. First you do inner conditional join. Okay, once you have done the inner conditional join, then add dangling tuples. Then add dangling tuples of both tables. Dangling tuples of both tables with null. Okay, is this clear? So in this question, actually what you will do, let me tell you. First, this is what you are going to do. Okay, first you are going to do the conditional join. This conditional join V, and the condition is A greater than V dot C. Okay, this A, this greater than V dot C. This would be greater than V dot C. So tell me, by this conditional join, what will be the schema? Because we are doing conditional join, so the schema will be A, B, C, D. Or schema will be like this: A, U dot B, U dot C, V dot B, V dot C, D. This will be the schema. Do you agree with me? Please tell me. So first you are going to do this. Okay, so this is the schema. Now you tell me what will be the tuples. So you can see A should be greater than VC. This A should be greater than VC. So this will be dangling tuple. I can say this is your dangling tuple. Next, what about this? A should be greater than VC. A. This should be greater than VC. So I can say this will combine with this one and this will combine with this one. Okay, I can say you will get like this: 4, 5, 6, 2, 3, 11, 2, 3, 10, 4, 5, 6, 2, 3, 11. Correct? Okay, next what you will do? This will pair with whom? Remember, A should be greater than VC. A should be greater than VC. So I can say this will pair with again these two. Again these two. So you will get 7, 8, 9, 2, 3, 10, 7, 8, 9, 2, 3, 11. Okay, so four tuples you will get first. Yes or no? First you will get four tuples. Now what is the second thing you will do? Second, add dangling tuples. Correct. Okay, second, add dangling tuples. Agree? Now tell me, add the dangling tuples of the both the tables. Okay, so you can see the dangling tuples. Which are those? This is dangling. Okay, so two dangling tuples are there. We have two dangling tuples. Agree? So these two dangling tuples you will put here. So you can see, let's put this 1, 2, 3, ABC. ABC 1, 2, 3. So put null, null. Okay, so the dangling tuples I am putting now. Okay, 1, 2, 3, null, null, null. Then I will put 6, 7, 8. Okay, then I will put 6, 7, 8. So like this, I will put 6, 7, 8. Sorry, 6, 7, 12. 6, 7, 12 and null, null, null. That's it. Is this clear? So this is your final answer. This is the final answer. You can see this on your screen. These are the dangling tuples. You can check it. This is the final answer. I hope you understood. Is this outer join clear? Please tell me. Is this outer join clear? Let me know. Very simple. Concept is very simple. Okay. You can see left outer join. So you can check it. This is your left outer join. First you do the natural join. Then you add dangling tuples of the left table. Right outer join. First you do natural join. Then you add dangling tuples of the right table. Then this is full outer join. First you do natural join. Then you add dangling tuples of left table and dangling tuples of right table. Okay. This is a meme you can see on your screen. This is the inner join, right? This is the inner join. Now, in the left outer join, we add the dangling tuples of the left table. In the right outer join, we add the dangling tuples of the right table. In full outer join, we add the dangling tuples of both left and right table. So you can see this. Okay, inner join, left join, right join, full outer join. Okay, and what happens with the cross join? In the cross join, what happens? Every tuple of R1 pairs with every tuple of R2. Yes or no? Every tuple of R1 pairs with every tuple of R2. So this is the meme for cross join. Okay. Very simple. Now let's move on. So we have seen this outer join concept. You can read this. Okay. You can easily see this, everything. Now let's move on. So we have seen this outer join. Okay. Now let's see this question. Tell me the answer for this question. Natural join. Give the schema. Given the schema, these schema are given R, A, B, C, D, S, A, C, E. What is the schema of R natural join S? Tell me what is the schema of R natural join S? Very simple. We will check equality of common attributes, but we only write one copy of the common attributes. Yes or no? Yes or no? So the answer will be A, B, C, D, E. This will be the answer. Okay. In the second question, what will be the answer? A, B, C, D. Here, because there is no common attribute. So here actually natural join will become same as cross product. Okay, so you will get A, B, C, D, E. Because there is no common attribute, so natural join becomes same as cross product. Here R, A, B, S, A, B. Okay, that will be what? So here natural join will be the schema of natural join will be, that's it, AB. Okay. Tell me one thing, very interesting thing here. Let me know one thing. If you have RAB, you are doing natural join with SAB, what will be the result? What will be the result? You are doing natural join. So natural join simply means what that means? That means equality of common attributes. Equality of all common attributes. All common attributes. Okay, means what should happen? A should be equal to A, means R dot A should be equal to S dot A, and and R dot B should be equal to S dot B. Okay, correct. So here what will happen? Intersection, right? Yes or no? Intersection will happen. Okay, agree. Basically, your answer will be same as the intersection. Only the common tuples, only the common tuples will be there in the output, because here you have AB, here you have AB. Yes or no? So, for example, this will match with this. This 1 2 will match with 1 2. This 1 2 will never match with 1 3. They will never match. So the answer will be same as intersection. Is this clear? Please tell me. Let me know. Understood? If you have AB here, AB here, means all the attributes are common attributes. Every attribute is common attribute. All the attributes are common attribute. Then the answer is same as intersection. Is this clear? Please tell me. Very simple point, right? Because you are checking equality of common attributes. So this must be equal to this must be equal to this. And in the answer, only the answer is schema. Schema you already know. Schema will be AB. The schema we have already seen. You can see RAB as AB. The schema of natural join will be this AB. Yes or no? Only two attributes. Only two attributes, because we will write one copy of common attributes. We only write one copy of the common attributes. So you can see the schema will be only AB. So finally, I am saying that this natural join, this, that is same as intersection. Okay. Tell me the answer for this question quickly. If you have two relation AB, A right outer join B on this condition. Okay. A right outer join B on this condition means first you apply this condition, find the inner join, then you add dangling tuples of the right table, then you add dangling tuples of the B. Yes or no? First you do the inner join based on this condition, then you add dangling tuples of B. So what will be the answer? So you can see all the rows of B will come. Do you agree? The answer will be option B. Okay, all the rows of B will definitely come, and matching rows of A will come. Only the matching rows of A will come. Okay, where there is no match in A, null values are used. So the answer for this question will be option B. Because remember, in the right outer join, all the tuples of B will come, right? Do you agree? If you have right outer join, then all tuples of S will be preserved. Here, all tuples of S will be preserved, right? All tuples of S come in output. Simple. So you can see all rows of B and only the matching rows of A. So the answer for this question will be option B. Now let's see the division operation. And this is very interesting operation, very easy operation. And there are many questions in the GATE exam from division operation. So let's see this division operation. First of all, let me tell you, we have seen 6 basic operations in the relational algebra. In the relational algebra, there are 6 basic operations. You can see selection, projection, Cartesian product, set difference, union, renaming. We have already seen all of them. Then I told you there are some additional operations, or I can say derived operations. Okay, there are some derived operations. Derived operators. So you can see these are the derived operators: intersection, natural join, conditional join, and division. So we need to study this division now. Okay, is this clear? So this division, this is a derived operation, you can see now. So let me tell you the syntax of division operation. The syntax first. Okay, let's see what is this division operation. This is very interesting and very important operation. So let me tell you about the syntax. The syntax is like this. R AB divide by SB. Okay, see, this type of syntax is there. Okay, basically, let me tell you, in this division operation, what happens? In this division operation, this should happen that R divided by S. Okay, remember this we write as R divided by S. Or what should happen? R, this set of attributes. Okay, let's call it X. Okay, divide by R, divide by S, this Y. Actually, what should happen? This X must be superset of Y. Okay, this X must be superset of Y. If you want to define this division operation, if you want to do R divided by S, then remember X must be proper superset of Y. Proper superset of Y. Superset of Y means X must be proper superset of Y, or I can say Y must be proper subset of X. So this is the syntax. Is this clear? So you can see RABSB. Okay, this is fine. This is perfectly fine. Now, so this is the syntax, very simple. Now, the output will be what? The output will be a table. The output will be a table with only A. Okay, you are dividing. See, AB divided by B. The output will have only this A. Now, what this output will contain, let me tell you. This will contain those values of A which pair with every value of SB in R. Okay, so let me tell you, this will contain what? Okay, this contains those values of A, because A is only in R, so I can say R dot A. Yes or no? Means those values of A which pair with every value of S dot B, which pair with every value of S dot B in R. Okay. So this, with example, this will become very clear, but I'm just telling you the syntax. See, understand the syntax. You have AB divided by B. So if you do AB divided by B, the output will have only A. Output will have only these values. So those values which pair with every value of SB in R. Okay, means, for example, this value, this pairs with every value in R. Okay, in R. Is this clear? So remember, this output will contain those values of A, because output will have only attribute A. So output will contain those values of R dot A, which pair with every value of S dot B in R. Okay, with example, this will become very clear. So is this syntax clear? If you want to do R divided by S, to define this R divided by S, I can say this R must be proper superset of this S. The schema of R, that must be proper superset of schema of S. Okay, so remember what is valid. For example, I can say what is valid. For example, this is valid, right? If I do, okay, RAB divided by SA, this is valid. Yes or no? This is perfectly valid. If I do, for example, RAB divided by SB, this is also valid. Okay, if I do, for example, RABCD divided by SBC, this is also perfectly valid, no problem. If I do RABCD divided by SACD, this is also perfectly fine. There is no problem here. Where is invalid? What is invalid? Please tell me. What is invalid? Invalid is like this. For example, if you do RA divided by SA, this is invalid. Because remember, this R must be proper superset of S. The schema of R must be proper superset of schema of S. So this is invalid. For example, if you do RAB divided by SBC, this is also invalid. If you do RAB divided by SCD, this is also invalid. Are you getting my point? Is this clear? So only valid. Valid means this schema of R must be proper superset of schema of S. That's it. I hope this point is clear. Like RAB divided by SB. So the answer will have only column A. Okay. You can see AB divided by B. So the column A will come in the answer. Those A values which pair with every B value in R. Okay. So let's see example with example. This will become very clear. So let's see this. You have R dividend and R2, that is divisor. What it means? It means I want R1 divided by R2. R1 is called dividend. Okay. In this situation, remember when you do R divided by S, in this situation, this is called dividend. Okay. This is called dividend and this is called divisor and this is called quotient. Okay, this is called quotient. Very simple. The result is quotient. So here, this is the dividend. We want to do R1 divided by R2. First, you tell me, is this allowed? Let me know, is this valid? First, you tell me that. Let me know. First, you tell me, is this valid? Like, for example, you have R1 AB. In R1, you have AB. You are dividing it. We are dividing it by R2, which have B. Yes, this is a valid syntax. Yes or no? So this is valid. This is perfectly valid. Okay, because schema of R1 is superset of proper superset of schema of R2. Okay, so now you tell me the answer will have what? You can easily see what we are doing. We are doing this, that. Notice we are doing R1. In R1 you have AB. We are dividing it by R2, which have B. The result will have what? Just tell me the result will have what? The result will have A. Yes or no? AB divided by B. AB divided by B. The result will have A. Okay, so the result, remember, the result will have A. The result will have A. So now remember, these values will come in the result. Now, which value of A? Now, will we put this value in the result? See, those values of A which pair with every value of B in R. So, for example, let's see this one. This one, look at this one. Is this one pairing with 1, 1? Like, for example, 1, 1, 1, 3. Are they in R? See, let's check one. Let's check this one. Tell me one thing. This one This one, does it pair with every value of B in R? Let's check this one. Does it pair with every value here in R? Like, do we have 1113? Do we have 1113? We don't have 13, right? So this one will not come in the output. This one will not come in the output. Okay. In the output, one will not come. Next, what about 2? What about 2? Now let's see. 2, is it matching with everyone? 2, is it matching with everyone, like in R? For example, do we have in R, do we have 2 1 2 3? We have 2 1, we have 2 3. Yes. Okay, so 2 will come in the output. What about 3? What about 3? Again, let's check 3. 3 1 3 3, do we have in R? 3 1 3 3, do we have in this R? We have 3 1, we have 3 3. Yes. So 3 will also come in the output. So the output will have only two values. Yes or no? So finally, remember, your output will have only two values. That will be 2, comma 3. This is your answer. Is this clear? Please tell me. This is the answer. Is this understood? Anyone has any doubt in this? So your answer will be this. And this answer, we call it quotient. Okay, means this R1, which has AB, you are dividing by R2, which has B. The result will be quotient. The result will be quotient, which will have A. Okay, so we have those A values. We have those A values which pair with every value of this divisor. Is this clear? Which pair with every value of divisor. That's it. So again, very simple note I can tell you that this is the idea. If you have R and you have AB divided by S, you have B, then your result will have A. Remember, your result will have A because AB divided by B, the result will have A. Okay, and in this QA, what you have? In this QA, we have those values of A which pair with every value of SB. Okay, we have those values of R dot A which pair with every value. of S dot B. Okay, which pair with every value of S dot B. That's it. So this will be your answer. Every value, which pair with all values of S dot B. Okay. So let's see these examples. These three examples we will see. We will find A divided by B1, A divided by B2, A divided by B3. Okay, so let's see all of them. First, let me see A divided by B1. So this is your A and this is B1. First of all, you tell me, is this allowed? Is this valid? Let me know. See, in A you have two things. One is S no, another is P number. Divided by B1, which has P number. First of all, is this valid? Let me know. Yes, this is perfectly valid. Okay, the output will be what? The output will be what? The output will contain only S number. The output will contain only S number. Means those S values which pair with every P number, which pair with every B1 dot P number. Yes or no? So remember, the answer will be the answer quotient that will have S number. Okay, you will have S number. So remember those S number which pair with every B1 dot P number. Okay, so you can see this S1, does it pair with P2? S1, you can see S1 P2. Yes, we have S1 P2. Okay, because of S1 P2, because of this S1 will come. Next, what about S2? Do we have S2 P2? Here, do we have S2 P2? Yes, we have S2 P2. So S2 is also here. What about S3? S3 P2. Do we have here S3 P2? Yes, S3 P2 is also here. Okay, so S3 is also there. What about S4? S4 P2. Do we have S4 P2 here? S4 P2. S4 P2. Do you have here S4 P2? Yes, S4 P2 is here. Okay, so S4 will also come. That's it. There is no other value in this. In this, there is no other value. So this will be your answer. Did you understand? You can notice these are those S numbers which are pairing with every B1 dot P number. Okay, so this is the answer. Very simple. Now let's move on. Now let's see this one. A divided by B2. Now you have P2, P4. So what will be the answer? Those S number which pair with every value here. Those S number which pair with P2, P4. So who is pairing with P2, P4? Remember A divided by B. So the output will have only S number. Okay, the output that will have only S number, right? S number. Now you can see those S number, the output will have these. In the output, you will put these. Those S number, which are pairing with both P1 and P2 and P4. You can see S1, S1 P2, S1 P4. So S1 will come. Okay, because of this and this. Because of this and this, S1 will come. Remember, S1 can pair with extra. Do you agree? S1 can pair with extra. But basically, those S number which pair with every B2 dot P number. Okay, so you can see S1 will come. What about S2? S2 P2, S2 P4. Do we have S2 P2, S2 P4? We don't have. So S2 will not come. Okay, S2 will not come. What about S3? S3 P2, S3 P4. S3 P2, S3 P4 we don't have. What about S4? S4 P2, S4 P4. Yes, S4 will come. So your answer will be this. Very simple, right? This division operation is very simple. Do you agree? Let's see this one, this example. Okay, let's see this. Again, A divided by B3. So the output will have what? The output will have only S number. Okay, the output will have only S number. Those S number which pair with every B3, which pair with every B3. Okay, means those S number which pair with every B3. So tell me who is pairing with every B3? P1, P2, P4. That is S1. You can see S1 is pairing with everyone. Yes or no? S1 is pairing with everyone. So the answer will be only S1. That's it. This is your answer. Simple. Because S1 is pairing with everyone. No one else is pairing with everyone. Only S1 is pairing with everyone. Simple, right? Correct. Now let's move on. So I hope you understood. This is your answer. So I hope you understood this. So again, I'm telling you that this is the idea, not the idea is like this. If you have R AB divided by SA, now tell me what will be the answer? R AB divided by SA, what will be the answer? The answer will have B. Now the answer will have B because AB divided by A. So the answer will have B. Now this QB will contain what? Now let's see. This QB means this will contain what? This will contain B values, right? On B values are here. So this will contain B values. This will contain those R dot B values which pair with all S dot A values in R. Okay, understood? Simple, right? Okay, we have those B values. The result will have those B values which pair with every S value in R. Okay, I can say those B values which are pairing with every S A values. Okay, those B values which are pairing with every S dot A values. That's it. So this is the division operation very easily you can see. Now let's see these two examples. A lot of examples I am taking. Let's see this example. We need to find what is R divided by S. We need to find what is R divided by S. We need to find what is R divided by T. Okay, this is what we need to find. So let's quickly find. Tell me what will be R divided by S. First of all, is that valid? R, I am dividing by S. Yes, that is valid. The output will have B. The output that will have B, right? Yes or no? So in the output, I will have those B values. Okay, those B values, please understand, those B values which pair with every S value. Okay, every S value. So tell me which B value is pairing with every S value, A1, A2, A3. This B1 is pairing with A1, B1 pairing with A2, B1 pairing with A3. So yes, B1 will come. Is there anyone else who is pairing with every S value, every S dot A value? Is there any B value that is pairing with every S dot A value? Like B2. What about B2? B2 is pairing with A1, B2 pairing with A3, but B2 is not pairing with A2. Okay, so B2 will not come. I can say that B2 will not come. Very simple. What about B3? B3 is not pairing with A1, so B3 will not come. What about B4? You can see B4 pairing with A1, A2, A3, so B4 will come. So the answer, remember, your answer will be only two values in the answer, that will be B1, B4. This will be your answer. Okay. Now let's see this. What is R divided by T? In R, you have AB. Now you are dividing by T, which has B. The result will have what? The result will have A. Okay, AB divided by B. The result will have A. In the result, you will have only the A values, which pair with every B value. So tell me, which A value is pairing with every B value? Okay, which A value is pairing with B1, B4? A1 is pairing with B1. A1 is pairing with B4. So A1 will come. A1 pairing with B1, B4. Yes or no? A1 will come. Next, A2, B1. Do I have A2, B4? Yes, A2, B4. So A2 will come. Next, what about next? Next, A3, B1. Do I have A3, B4? Yes, A3, B4. So A3 will come. Next, what about the next? A4, B1. Do I have A4, B4? A4, B4. I don't have A4, B4, right? I don't have A4, B4. So A4 will not come. That's it. Okay. So this is your answer. A1, A2, A3. Simple, right? Agree? Okay. Let's see this. What is the answer for this one? First of all, is this valid? Let me know. We are doing R, A, B, C, D. R has A, B, C, D, E. We are dividing by S, which has D, E, which has D. Yes, this is valid because this schema is proper superset of this schema, the result will have what? The result will have ABC. ABCDE divided by DE. So the result will have ABC. Yes or no? In the result, you will have ABC. The result will have ABC. So remember, in the result, you will have these three: A, B, C. So those ABC, remember those ABC which pair with every S dot DE. Those which pair with every S value. Yes or no? Those ABC which pair with every S value. So tell me, what about alpha A alpha? Will it come? Alpha A alpha, alpha A alpha A1, alpha A alpha. No, alpha A alpha is only pairing with A1. So alpha A alpha will not come. What about alpha A gamma? Yes, that is pairing with both of them. Alpha A gamma. So alpha A gamma will come because you can see that alpha A gamma is pairing with both of them. Okay, next, what about the next? Next, beta A gamma. That is not pairing with both of them. Yes or no? We don't have beta A gamma B1. Okay, we don't have beta A gamma B1. Next, gamma A gamma A1, gamma A gamma B1. Yes, this will also come. So gamma A gamma, this will also come. That's it. So the answer will be this. Okay, is this clear? Very simple. Now let's move on. So you can see the answer is these two. These two are the answer. Now let's move on. Okay, tell me here, what is R1 divided by R2? Quickly tell me, what is R1 divided by R2? What that will be? That will be invalid. Yes or no? Because you can see here you have AB, here you have BC. So this is not a proper superset of this. So this is invalid, right? Okay, this is invalid. Very simple. Now let's move on. Can I give this question as a homework? Let me know. So please take this question as a homework. Okay, pause the video, solve this question, put your answer in the comments. In this question, these are the options. Okay, so remember, this is your question and these are the options. So you tell me in the comments, you let me know which option is correct, A, B, C, D. Which option is correct? You tell me in the comments. Pause the video, solve this question. Now let's solve this gate exam question. You can very easily solve it. Consider a database that has relation schema CR, student name, course name. An instance of this schema CR is given below. So this schema is given to us. This table is given to us CR. The name of the table is CR. There are two columns you can see. Now the question is asking, the following query is made on the database. This is the following query. First, this T1 we are calculating, then T2 we are calculating. So first you calculate T1, then T2. The number of rows in T2. Okay, so this is a very simple question. Let's solve it. First, what we are doing, let me know. First, we are calculating T1. Tell me. First, let's calculate T1. Then let's calculate T2. So tell me, if I calculate T1, then what I will get? Remember what is T1? T1 is from CR. You select those tuples where student name is SA. Those courses you find. Okay, then we are projecting the courses. Remember, from the CR table, we want those tuples where student name is SA. These tuples we want, and we only want to project course name. We only want course name. So in the T1, remember, I only want course name. Remember, I only want course name where, and remember, these tuples I want where student name is SA. From this table CR. From this table CR. So this is the query. This is your query T1. From the table CR, you select those tuples where student name is SA, then you project course name. So tell me, what will the table T1? In the table T1, we only have one column because we are only projecting course name. Correct? We have only one column, that is course name. Course name. So tell me, what we will get? You can see from the CR table, this is your CR table. Those tuples where name is SA. where student name is SA. So where is student name SA? You can see this tuple will pass. Okay, these tuples will fail. See these tuples. Okay, only SA tuples. All the remaining tuples will fail. Okay, I want courses which SA has taken. SA courses I want. So those will be CA, CB, CC. These are the courses which SA has taken. Okay, so this is your T1. Now we have T1. Remember, now we have T1. What is T1? In T1 we have course number, course name. Okay, what are course names? That is CA, CB, CC. CA, CB, CC. This is your T1. Now what we need? Now what we need to do? Now in the T2, CR divided by T1. Please understand, is this valid? CR divided by T1. In this CR, what we have? In this CR, we have student name, course name, divided by T1. In T1, we have course name. So is this valid? Yes, this is valid, right? In the CR, we have student name, course name, divided by T1, which has course name. The result will have what? The result is T2. The result will have what? Remember SN CN divided by CN. So in the division, the result will have only SN. Okay, those SN which pair with every T1 dot CN. Yes or no? Okay, basically the output will be what? Remember those SN which pair with every T1 dot CN means what that means? These are the courses taken by student SA. Yes or no? Remember, these are the courses taken by student SA. In the T1, we have courses taken by student SA. Do you agree? Courses taken by student SA. Okay, so this is your T1. These are the courses taken by student SA. Now what we want? Now we want those student names. We want those student names which pair with every course taken by SA. Okay, so the result will be what? Remember the result. The result is those students, because in the output we will have student name. So we will have those student names who have taken every course taken by SA. Every course taken by SA. Do you agree with me? Please tell me, did you understand? This is the answer. Okay, those students who have taken every course taken by student SA. Clear? Let me know. Is this understood? Because remember, first we are calculating T1. In the T1, we have those courses which are taken by student SA. This is student SA. Those courses we have. Now we are calculating T2. T2 means CR divided by T1. CR has student name, course name, divided by course name. So the output will have student name. So we will have those student name. Remember, we will have those student name who has taken all the courses of T1, all the courses of T1. So I can say those student names who have taken all the courses taken by SA. So tell me, which students have taken CA, CB, CC? Let me know. Which students have taken CA, CB, CC? CA, CB, CC. Because this T1 has CA, CB, CC. So which students have taken CA, CB, CC in this table? So you can see, yes, SA. Okay, so you can see SA will come. Definitely SA will come. In T2, you have SN. This is your T2. This is your table T2. Okay, so you can see in the table T2, S name. So student SA has taken all the courses by SA. I can say SA has taken all the courses of SA. Yes. Okay, what about SB? SB has taken CA, CB, CC. Let's check. SB has not taken all these. SB has not taken all these courses. What about SC? SC has taken CA, CB, CC. So SC will come. Next, what about SD? SD has taken, remember, SD has taken CA, CB, CC. So SD will come. Next, what about SE? SE has taken, sorry, SE. Let's check SE. SE has not taken CC. Okay, what about SF? SF has taken CA, CB, CC. So SF will come. Okay, is this clear? So the final answer will be four tuples in T2: SA, SC, SD, SF. Remember, these are those students who have taken all the courses taken by SA. Yes or no? These are those students who took all courses taken by SA, who took all courses taken by SA, taken by SA. So very simple. So these are the four students who have taken all the courses taken by SA. So your final answer, the number of rows in T2, that will be 4. So answer is 4. This is your gate exam question. Is this clear? Please tell me. Let me know. So very simple. Now let's move on. Now let's see division operation in terms of basic operators. And this is very important. You can see there are many gate questions on this concept. Division operation, how can we write in terms of basic operators? Okay, let's see this table R which has kids comma games and S which has games. Then tell me, is this valid? R divided by S? Yes, this is valid because the schema of R is proper superset of schema of S. So this is valid. Now tell me what will be the result? Kids comma games, and here you have S dot games. So the result will be what? Result will be what? The result will be those kids. Yes or no? The result will have only kids. The result will have only kids, and these are those kids. These are those kids who have who have who have played every S dot game. Yes or no? Who have played every S game? Do you agree with me? Who played every S game? Yes or no? Agree with me? Basically, those kids which play every S game. Can these kids play extra game which is not in S? Can they play extra game which is not in S? Yes, they can play. For example, let's assume there is a in S game. Let's assume you have two games. Okay, there are two games. Let's assume one is, let's assume, football. Okay, one game is football, another game is cricket. Okay, and let's assume this is another game. Okay, javelin throw, famous by Neeraj Chopra. So you can see, let's assume that these are the game. These are, let's assume this student is playing football also. This student is playing cricket also. This student is playing this game also. This student is playing, let's assume, some extra game, maybe table tennis. Okay. And let's assume this student is playing only cricket. So tell me, in the output, what you will have? In the output, what you will have? In the output, you will have those kids who are playing every S game. So A will come because A is playing every S game. A can play extra game, right? Do you agree? A can play extra game, but A is playing every S game. So remember, this R divided by S, this will give me kids, those kids who have played every S game. I hope this point is clear. Now, how can you write this R divided by S, this division, in terms of basic operations? So implementation of division using basic operators. Let me tell you the idea. Okay, the idea is very interesting. See, the idea is very interesting. Let's assume you have R which has AB divided by S which has B. Okay. So you know the result. You already know the result. Result will have A values. Okay. So here I want those A values which are pairing with every S dot B. Yes or no? I want those A values. I want those A values, or I can say I want all those R dot A values which which pair with every S dot B values in R. Yes or no? Do you agree with me? Which pair with every S dot B values in R. Okay, so this is what I want. You already know. So if I want this, then what I can do? Just understand. Then what I can do? This is the idea that what I will do. First, I will find the total students. Okay, all the A values, because remember the output will have A values. So let me find all A values. Okay, let me find all R dot A values. This is what I will find. All R dot A values. Now I will remove which one? I will remove those who are disqualified. Okay, yes or no? I will remove those which are disqualified A values. Now tell me, when can you disqualify some A value? Please tell me, when will you disqualify some A value? All R dot A values minus disqualified R dot A values. Let me know, when will you disqualify some R dot A value? When it does not pair with some S dot B value. Yes or no? Remember, these are those R dot A values disqualified. Disqualified are those R dot A values which do not pair with some S dot B value. Which do not pair with some S dot B value. Do you agree? So far, do you agree with me? Some S dot B value. Okay. Is this clear? Very simple. I want, remember, RAB divided by SB. The result will have A values. The result will have those A values, those R dot A values, which pair with every S dot B values. Okay, yes or no? Now, what I want, remember, from all the RA values, from all these A values, if I remove disqualified values, disqualified, when will you disqualify some R dot A? We will disqualify those R dot A values which do not pair with some S dot B values. Okay. Now, how to find these disqualified values? See, how to find disqualified values. This is what I want. I have RAB divided by SB. I want disqualified A values. Then tell me how to find this. Disqualified A values, R dot A values, which are disqualified. Okay, means which do not pair with some SB values. So how to find the disqualified A values? Let me tell you this idea. Understand this idea. Tell me, ideally what should happen? Ideally, this A value must pair with every B value, SB value. Do you agree with me? See, ideally, please understand, ideally what will happen? Let me know. Ideal, ideally what will happen? Ideally, these A values will pair with every SB values. Okay. Now, from the ideal situation, if I remove the actual situation, this is giving me actual situation, which A value is pairing with B value. This is giving me actual situation. This, okay, this is giving me actual, which A value is pairing with B value. So, ideal situation is that every A value, I can say these A values, they will pair with every B value. This is the ideal situation. If I remove the actual situation, then what I will get, let me know. From the ideal, if I remove actual, then what I will get? Just tell me this point. From the ideal, if I remove actual, then what I will get? These are A values. Ideal minus actual. What will be these are A values? Please tell me. Let me know. These are disqualified. Yes or no? Is this clear? See, from ideal, if I remove actual, then these are those values which do not which are not pairing with some SB values. I can say these are those R dot A values. These are those R dot A values which ideally should have been there but not there. Which which ideally should have been there but not actually there. Those R dot A values which are disqualified. Yes or no? Which ideally should have been there. Which ideally should have been there. Which ideally should have existed, should have been there, but not actually. But they are not actually there. Okay. But they are not actually there. So they are disqualified or not? Okay. So these are disqualified. So these are disqualified R dot A values. I hope you understood. See, if you did not understand, do not worry about it. Okay, I will explain this. But anyway, let me tell you the overall idea. See, the idea is very important. You will not make mistake if you understand the idea. The idea is like this. I have RAB divided by SB. You know the result. You know that result will have A. Okay, you know the result will have A. Okay, those A values which are qualified. So remember, the idea is like this. Qualified A values. Okay, the result is qualified A values. Qualified A values is equal to R dot A values is equal to is equal to all r dot a values minus disqualified. Yes or no? Minus disqualified r dot a values minus disqualified disqualified r dot a values. Okay, now how to find this disqualified r dot a values? So let me tell you. Okay, if I want disqualified values, disqualified r dot a values, this will be equal to, okay, which values will be disqualified? Which ideally they should have been there. Ideally they should be present, but they are not actually present. Yes or no? They ideally should be present, but they are not actually present. So disqualified r dot a values will be, ideally they should be present, minus actually they are not present. Okay, yes or no? These a values, these are the disqualified r dot a values. That's it. This is the answer. Now let's see example. With example, this will become very clear. So this is your table S number, P number. This is your table P number. Okay. So first you tell me what will be A divided by, A has S number, P number, right? A has S number, P number. Tell me what will be this divided by B to P number. Tell me the result first. Okay. The result will have S number. You already know the result will have S number. Okay. In the result, what you will have? Those values which pair with every b2 value. Yes or no? those those s numbers, because the result will have s number, those s number which pair with every b2 value. Okay, so you can see those s number which pair with p2 p4. So I can say there will be s1 with p2 p4, there will be s4, these will be there. Okay, yes or no? S1 S4, these will be there. Correct? Now you tell me, first of all, you tell me all. If I ask you, you know the idea, right? Okay, you know the idea. Idea is what? Idea. You know the idea. That is what we will do. We will find all S numbers minus disqualified S numbers. Do you agree? Okay, one by one. All S numbers minus disqualified S numbers. Tell me what are S numbers? How to find all S numbers? Just tell me this point. This is very easy. You know the idea. Idea is all S number minus disqualified S numbers. Now you tell me how to find all S numbers. How to find all S numbers? Very simple. Just project S number from this table. Just project S number from this table. Very simple or not? Okay, just project S number from this table. These are all the S numbers. Okay, now how to find this? This will be interesting. Disqualified S number. I want disqualified S number. Okay, disqualified S number. This is what I want. So how to find disqualified S numbers? That will be the ideal minus actual. Okay, the ideal minus actual. Now, what I mean by ideal? See, ideally, what should happen? That S number should pair with every B2 value. Yes or no? See, the ideal will be like this. Ideal will be that S numbers pairing with every B2 value. It's like this. You take the S numbers. Okay, you take S numbers from the table A. Okay, you take S numbers. You take S numbers. And they should pair with every B2 value. So cross with B2. Yes or no? So cross with B2. This is ideal or not? Please tell me. Is this ideal or not? See, ideally what should happen? Ideally notice that these S number, they should pair with every B2 value. Do you agree with me or not? Ideally, these S number, they should pair with every B2 value. So what you do? Ideally, these S number, you find the S number, cross product with B2. This is ideal situation. From this ideal situation, what is the actual situation? Which S numbers are actually pairing with the P number? Which S number are actually pairing with P number? That is your table A. So minus table A. Minus table A. Yes or no? Okay. From this, what you give me? You just give me the S number. Those are disqualified S number. Okay, from this you give me S number. Those are disqualified S number. Okay, from this you project S number. These are disqualified S number. Is this clear? Please tell me, did you understand or not? Let me know. Did you understand or not? Let me know. These are the S numbers which are disqualified. Now you know the answer. Now you know the answer. The answer is A divided by B2. That is equal to, okay, A divided by B2. That is equal to all S numbers. Okay, that is equal to all S numbers minus disqualified S numbers. Disqualified S numbers. Okay, and what are all S numbers? All S numbers, what are those? Very simple. Just take S number from table A. These are all S numbers minus. What are disqualified S numbers? Disqualified means, okay, let's see disqualified S numbers. Those are ideal minus actual. Actual is this. Actual is table A. This is the actual table. Means this is actually the S number which are pairing with the P number. This is the actual situation. S number, P number pairs. Okay. Ideally, these are the pairs. Ideally, that they should pair with B2. Okay. Ideal situation is this, that pi, you find S number from A. Okay. Cross product with B2. This is ideal situation. From ideal minus actual, and then you project S number. This is your answer. That's it. That's it. This is your answer. Remember, all S number minus disqualified. These are disqualified. Please tell me, did you understand? Let me know. Let me know. Let me write it. See, this is actually very easy. Let me write it. For example, if you have AB, okay, and you divide by S, which has B, you know the result. You already know the result. The result will have only A values. Okay. So I want only A values. Now remember, the idea is this. The idea is this, that you find all A values, you find all A values minus you remove disqualified A values. Okay. Disqualified A values you remove. Yes or no? From all A values, remove the disqualified A values. Now, all A values, this is very easy. All A values, how to find? Project A from R. Project A from R. These are the all A values. Now, how to find disqualified A values? That will be what? That will be ideal minus actual. Okay, that will be, see, ideal pairs minus actual pairs. Ideal pairs minus actual pairs. Ideal pairs minus actual pairs. Okay, so ideal pairs are what? Ideal pairs means these A values, they should pair with every SB values. Ideally, these A values, they should pair with every B value. So ideal pairs are like this. You take these A values from R, you do cross product with S. You do cross product with S. This is ideal. This is ideal. Okay. Minus actual is already this table. This table is actual pairs. This table is actual pairs. Okay. Now this, from this, you take A values. This is your disqualified. Okay. And then you do minus. This is your minus. This is your final answer. Okay. Understood? Let me know. Please tell me, did you understand or not? Anyone has any doubt in this? Let's see one more example so that it will become very clear. Okay. See, let's see this example. You have this table and I want A divided by B3. So tell me, if I do A divided by B3, what I will get? I will get S number. Yes or no? I will get S number. So you tell me about what are the all S numbers. Let me know. How to find all S numbers? Just tell me this point. I want all S number. Then that is very simple. From the table A, you project S numbers. This will give you all the S numbers. Now you tell me about disqualified S numbers. How to find disqualified S numbers? Tell me how to find disqualified S number. See, the ideal pairs, you find ideal pairs. Okay, you find ideal pairs minus actual pairs. These are disqualified. Ideal pairs minus actual pairs. and from them you project S number. So tell me, ideal pairs are what? Just tell me, ideal pairs are what? Let me know. Who are the ideal pairs? Let me know. Who are the ideal pairs? Ideal pairs means these S number, they should pair with every B3 value. Ideal pairs, these values should pair with every B3 value. So cross product you will do. Okay, means these values. Okay, means, okay, from A, you project S number. They should pair with every B3 value. So do cross product with B3. These are the ideal pairs. Okay. Yes or no? Ideal pairs. And what are the actual pairs? Tell me, what are the actual pairs? What are the actual pairs? Let me know. The actual pairs are table A. Table A is the actual pairs. So tell me, what are the disqualified? What are the disqualified? Disqualified S number. What are those? Disqualified S number. That is ideal minus actual. You know the ideal. Ideal is from table A, you project S number, do cross product with B3. This is ideal minus actual. Actual is A. Okay, from this, you project S number. You project S number. So these are disqualified S number. Yes or no? Now you have disqualified, then your answer will be what? Answer will be all S number minus disqualified S number. Minus disqualified S number. Okay, so all S number, what are those? All S number that you already know, that is you project S number from A. These are all S number minus disqualified S number. You project S number from this. Okay, means these are the actual minus. Okay, you do S number from A cross product with B. That's it. Okay, that's it. Is this clear? Let me know. Understood this? Please tell me. Did you understand? So this is very simple. I hope you understood. Okay. So for example, just quickly tell me from this example point of view, what are disqualified? What are disqualified pairs? You tell me about disqualified pairs. You just tell me about disqualified pairs. See, for example, what are disqualified pairs? You can see here. Remember, this will be the output. Okay, so disqualified pairs, what are those? For example, you can see B1, A1, B1, A2, B1, A3. Okay, you can see B1, A2, A1, A2, A3. So this is not a disqualified pair. Okay, B2, B2, A1, B2, A3. So you can see disqualified pair is, you can see B2. Yes or no? B2, A2, B2. Yes or no? A2, B2 is disqualified. Agree or not? Because ideally this should be there. Do you agree with me? Ideally this should be there, but it is not there. Ideally this should be there, but it is not there. Do you agree? Ideally this should be there, but it is not there. What else is disqualified? What else is disqualified? A1, A2, A3. So another disqualified is A1B, A1, B3. Because this should be there, but it is not there. These are ideal minus actual. These are ideal minus actual. What else? You can see B4 is fine. Okay, so remember these are disqualified pairs. These are ideal minus actual. These are ideal minus actual. Okay, so anyway, I hope this point is clear. Now let's move on. So is this clear? For this, how you will write? Let me know how you will write for this one. For example, here you can see you have R, A, B, C, D, E divided by S which has D, E. The result will have what? The result will have ABC. The result will have ABC. So tell me how you will write the query in terms of basic operators. So here you can see this R divided by S. This will be, okay, you find all the ABC values. Okay, yes or no? You find all ABC values. Do you agree? Okay, you find all ABC values. minus what you do, disqualified ABC values. Okay, you do disqualified ABC values. Okay, so tell me how to find all ABC values. Let me know how to find all ABC values. That is, project ABC from R. These are all ABC values. These are the all ABC values minus. Okay, minus what I will do, disqualified ABC values. Okay, ABC values which are disqualified. ABC values which are disqualified. So what I will do? Very simple. Ideal minus actual. Actual is already table R. Actual is already table R. Ideal minus actual. Ideal means what? These ABC values, they should pair with every value of S. Ideally, these ABC values, they should pair with every value of S. So we should do cross product of these two. This is ideal. So ideal is like this. Ideally, ABC of R cross product with S. This is ideal. Ideal minus actual. Okay, then you project. These are the disqualified ABC values. From all ABC values, you remove disqualified ABC values. This is your answer. Is this clear? Please tell me. See, this is important. That is the reason I am repeating it many times. I have repeated already many times. So this is what we have seen. And let me tell you, this equation is given by Helly. So this is called Helly's division. Okay, so finally, this is the conclusion. Let me tell you the conclusion. If you understood very good, else you should remember it because this is very important. So the conclusion, let me tell you, the conclusion is like this. If you have R, okay, if you have RAB divided by SB, you know the result. You know the result. The result will be A. Okay, you know the result. So tell me how to write this R divided by S. How to write this in terms of basic operations? You find all the A values because the result will be A values. So you find all the A values minus disqualified A values, minus A values which are disqualified. And to find disqualified, what you will do? Ideal minus actual. Actual is table R. And ideal means this A, this will cross product with S. Okay, so you can see this A, this will cross product with S. This is ideal. Okay, so that's it. So this is the answer. So remember, these are disqualified. These are disqualified R dot A values. Okay, and these are all R dot A values. Okay, one more thing I want to ask you. Disqualified R dot A values, that means what? That means what? Disqualified R dot A values means in the gate exam, they can give you this equation and they can ask you what this gives you. Tell me what this means. This equation gives you which A values? This gives you those A values. These are disqualified. So those are dot A values which do not pair with some S values. Yes or no? Which do not pair with some S dot B values in R. Okay, yes or no? That is the reason these are disqualified because they do not pair with some S value. They do not pair with at least one S value. So that is the reason they are disqualified. Okay, so very simple. Now in the gate exam, they can also give you the equation like this. See, R is there divided by S. Okay, let's assume this is valid. Let's assume this is valid. Valid means what? If this is valid, then it means what? Then it means schema of R is superset of schema of S. Yes or no? Yes or no? Schema of R is a superset of schema of S. Proper superset of schema of S that you already know. Now, if this is valid, then how to write this? Very simple. I told you, you find all R minus S values. Yes or no? Okay. Because the result will be R minus S that you already know. See the result. The result will be R minus S attributes. Do you agree? In the result, you will have R minus S attributes. R attributes minus S attributes. That will be your result. So first you find all these values. Okay, first you find basically from R, you project R minus S. These are the all R minus S values minus disqualified R minus S values. What are disqualified R minus S values? So let's see, that will be all minus ideal. Ideal is R. Okay, ideal is R. Let's assume, see, I'm using small for instance and capital for schema. This capital I'm using for schema and this small I'm using for instance. Okay, so that it is clear. So that it is clear that here I'm using schema means schema of R minus schema of S. Okay, and this small I'm using for R. So this is your actual. Now what you do? Ideal is what? Ideal means these R minus S from R. Okay, you do cross product with S. Okay, you do cross product with S. That's it. So this is your answer. Okay. So we have seen this many times, but I hope you understood this. Did you understand Helly division? Did you understand implementation of division using basic operators? Did you understand? Because this is important for the GATE exam. Let me know. Did you understand? So we have seen this equation, like, okay, this equation we have seen pi a minus this. Okay, so we have already seen this. You can see this is a GATE exam question. This is GATE 2009 question. Please tell me this first equation. What is this first equation? This first equation. Remember, R is there, ABC, S is C. So look at this first equation. This first equation is basically division. Yes or no? Look at this first equation. This is basically R divided by S. You can easily see. You can easily see because, see, R divided by S, the output will have R minus S schema. The schema of output will be R minus S. Okay, that you already know. So here you can see, first we are finding all R minus S. Then we are removing disqualified. Okay, so this we have already seen. Basically, in this GATE 2001, in this GATE 2009 question, you can see option 1, that is your division operation, R divided by S. This we have seen. We have already seen. Okay, I hope you understood. Can I give this question as a homework? This is a beautiful question. In this question, you can see that this is your quotient. This is your divisor. And this is your dividend. You can see R divided by S is equal to T. Now what the question is asking, see, it is already given. What is the result? That is already given. Now in the question, this is asking which tuples must be added to R. In this R, which tuples must be added so that B2 belongs to result T. Okay, which tuples I should add so that B2 belongs to this result. Similarly, which tuples we should delete from R so that B4 does not belong to the result. So this is a beautiful question. Please take this question as a homework. Pause this video right now. Solve this question. Write your answer in the comments. Now, now let's see another implementation of division. This has not been asked in the GATE so far. So should I discuss this? This another implementation. This has not come in the GATE exam so far, but in the future they can ask. Okay, so let me tell you, this is very easy actually. This another implementation of division. This is actually very easy. You tell me one thing. See, in this division, what we want? We want those as number which pair with both P1 and both P2 and P4. Yes or no? Okay, agree. So you know that in the division, we want those as number which pair with both P2 and P4. You just tell me a simple point. Okay, if I find which S number are pairing with P2, okay, means for this P2, I find which S number are pairing with it. Are you understanding? See, if I find S numbers pairing with P2, S number pairing with P2, pairing with P2. Please understand. S number pairing with P2, I find. I also find S number pairing with P4. I also find S number pairing with P4. Then tell me, what is my desired answer? What is my desired answer? I find S number pairing with P2. Okay, means which S number are pairing with P2? Like this is pairing with P2, this is pairing with P2, this is pairing with P2, this is pairing with P2. I find S number pairing with P2. Okay, so what are those? Tell me. S number pairing with P2, those I find. So what are S number pairing with P2? Let me know. Like you can see S number pairing with P2, 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 P2. So S number pairing with P2, those are S1, S2, S3, S4. Okay. And you tell me what are S number pairing with P4? P4, P4. S number pairing with P4, those are S1, S4. Tell me what is the desired answer. Please tell me what is the desired answer. Remember, desired answer is those S number which pair with this also and this also. Do you agree? Which pair with this also, this also. So intersection I will take. So intersection I will take. Do you agree? This is interesting, right? Yes or no? This is another way. This is interesting. I hope you are finding this interesting. Please understand, in the division, we will have those S number which pair with this also and this also. So what I do? First, I find those S number which are pairing with P2. Then I find those S number which are pairing with P4. Now I am looking for intersection. So I will take their intersection. So my desired answer will be, so remember, A divided by B2 will be intersection of these two. Okay, yes or no? So that will be intersection of these two. Okay, for example, for a moment, let me call it M, let me call it N. Okay, so for a moment, let me call it. So the answer will be, or I can say, let me call it result when I'm getting result for P2, and this is result for P4. So the answer will be R2 intersection R4. Okay, basically what I'm saying you just do their intersection. This is the answer. I hope this method also you are finding this interesting. This is very interesting method. Okay, so let's see another example. Let's see this example. Okay, so first of all, you tell me you have R which has AB divided by S which has A. The result will have B. Do you agree? The result will have B. Now you tell me in the division I want those B values which pair with every A value. Yes or no? I want those B values which pair with every S value, which pair with every S value. Okay, so instead of this, what I can do? Please notice something interesting I am doing. I will find B values pairing with A1. Okay, let me find B values pairing with A1. Okay, then I will find B values pairing with A2. Okay, I will find B values pairing with A2. Then I will find B values pairing with A3. Okay, yes or no? So tell me, what is my desired answer? Tell me which B values I want. See, here I am finding B values, B values, B values. Ultimately, my desired B values are what? I want those B values which pair with this also, this also, this also. Yes or no? Do you agree? I want those B values which pair with this also, this also, this also. So I want intersection of these. Yes or no? I want intersection of these. That will be my desired answer. Okay, if I take intersection of these, that will give me R divided by S. Okay, you can check it. You can check it. What are the B values pairing with A1? Which B values are pairing with A1? So you can see pairing with A1. Okay, you can see A1, A1, A1. So which B values are pairing with A1? That is B1. Tell me which A values, which B values pairing with A1? So that will be B1, B2, B4. Now tell me which B values are pairing with A2? Now tell me this A2. This is A2, A2, A2. Yes or no? A2, A2, A2. So that will be B1, B3, B4. B1, B3, B4. Okay, and tell me which values are pairing with A3? A3, 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 A3. So that will be B1, B2, B3, B4. B1, B2, B3, B4. Now I will take their intersection. Do you agree? What is their intersection? The intersection is B1, B4. And that is my desired answer. Okay, yes or no? That is my desired answer. So the desired answer is The desired answer is B1, B4. You can check. You can check B1, B4 are pairing with every S value. Okay, understood? So is this implementation clear? And do you think after knowing about this implementation, do you think this can come in the gate exam? Do you think in the gate exam they can ask you this implementation? Because this is another idea. How to find division, how to find result of division operation. This is another idea. Yes or no? You are basically doing the intersection. So this idea they can ask you in the gate exam, but so far they did not ask in the gate exam. Okay. So ultimately, I'm writing it. Remember, the idea is like this. Okay. Let's assume you have R, which has AB, divided by S, which has B. Okay. In S, let's assume you have some B values like B1. In S, you have B1, B2, and so on. Let's assume some B values you have, right? Okay. Your B values. Now, here you have, this is your table R. Okay. So what I will do, you already know the result, right? The result is, the result is A values. So the result will be A values. So what I can do, what I can do, I can do this. I can find A values pairing with B1. Okay. I can find all A values pairing with all A values pairing with B1, pairing with B1. Okay. Then I can find all A values pairing with B2. Yes or no? Then I will find all A values pairing with B2. Which A values are pairing with B2? Then I will find all A values which are pairing with B3, pairing with B3, and so on, and so on. I will find all A values pairing with Bn. Okay, and then what I will do? Tell me. What is the desired answer? A values pairing with B1, A values pairing with B2, A values pairing with Bn. Desired answer is those A values which pair with every B value. Desired answer is those A values which pair with this also and this also and this also and this also. So I will take the intersection. So the desired answer is intersection. Okay, intersection. The desired answer is the intersection of all of them. Okay, so in one line, how to write this? In one line, how to write this? You tell me, how will you find A values pairing with Bi? Let me know. Let me know. For example, A values pairing with B1. How will you find? Tell me, how will you find all A values pairing with B1? How will you find? Let me know. A values pairing with B1. Very simple. Very simple. Pairing with B1. I want all A values that are pairing with B1, means those A values which are pairing with B1. This is what I want. Yes or no? So very simple. This is very simple. From the R table, you select tuples where B equal to B1, and then you project A. Agree? Do you agree? Please tell me. Let me know. I want A values which are pairing with B1, which are pairing with B1. A values that are pairing with B1. All A values which are pairing with B1. So very simple. From the table R, you can see this B, this must be equal to B1. Yes or no? And I will project pi A. I will select these tuples. I will select these tuples where B value is B1. And then I will project A. Yes or no? Okay. So the same thing I will do with what? Same thing I will do with B2. Same thing I will do with B2. Okay. For B2, the equation will be what? For B2, the equation will change like this. Okay. Because I will find A values pairing with B2. Which A values are pairing with B2? This is what I will find. Okay. Correct. Like this. And so on. So finally, I will take the intersection of all of them. So remember, for every BI, I will do this. Yes or no? From the table R, I will select those tuples where B is equal to BI, where B is equal to BI. For every BI, I will do this. Okay. Then I will select, then I will project attribute A. Okay. So this I will do for every BI, and then I will take intersection. Then I will take intersection, and remember, I will do this for every BI belonging to B. This is my answer. This is the equation. I hope you understood. This is the equation for R divided by S. Let me know. In the gate exam, they can give you this equation, remember. In the future gate exam, they can give you this equation. Did you understand this method? Let me know. This equation, did you understand? The proof of this equation, did you understand? Please tell me. This idea, did you understand? That we can find the division with help of intersection. Basically, we are basically doing the intersection of all A values, okay, which are pairing with each BI values. So you can see, like this we can do. I hope you understood. So for example, look at this. This is your kids comma game, and here you have games, here you have s dot games. Now tell me, if for every s dot game we find the kids who play those s games, then what will be the intersection of these kids? See, for every game here, for every game here, I find the kids who are playing that game. Okay, for let's assume here you have cricket, football. For cricket, I find kids who play cricket. For football, I find kids who play football. Then if I do the intersection of these kids, then what I will get? Then I will get those kids who play every S game. Those kids who play every S game. So if I do intersection of these kids, then what I will get? I will get R divided by S. Okay. If I do intersection of these kids, I will get R divided by S. So this is your equation. In the GATE exam, they can ask you this equation. This is called Mayer's equation, but this is very easy to understand. Okay, this equation is called Mayer's equation, but actually this equation is very easy to understand. So let me write this conclusion. I hope you understood, but let me write this conclusion. This equation is actually very, very, very easy. Okay, see, you have R which has AB divided by S which has B. You know the result. You already know the result. The result will be Q which will have A values. Okay, so remember now how to find these A values. The This is actually very easy. How to find A values? So very simple. For every S value, remember, okay, for every S value, I will find A values which are pairing with, for example, here if I have B1, then for this B1, I will find A values which are pairing with the B1. So remember, from the table R, I will select those tuples where this column B is equal to BI. Okay. Yes or no? Then I will project these A values. And remember, I will take the intersection of these A values. I will do this. Remember, I will do this. This I will do for every BI belonging to B. And then I will take the intersection. So this is the equation. Okay. So I hope this is clear. So actually this is happening that this I will do for every BI. Okay. This is basically done for every BI belonging to S. Okay, we will do this for every BI belonging to S. And then we will take intersection. Okay, then take intersection. Then take intersection of all. So this is the idea. Okay, let's move on now. So very simple. This is what we have done. I hope you understood. Now, let me cover this topic, maximum and minimum cardinality of division operation. What the maximum cardinality, what is the minimum cardinality? If this is your table R, A, B, S, B, and they are non-empty, R has n tuples, S has m tuples, then what is the maximum and minimum cardinality of R divided by S? Tell me. You have R which has AB and you have S which has B. Both are comma S non-empty. They have at least one tuple. Okay, both are non-empty. Now you tell me, what is the minimum cardinality of R divided by S? What are the minimum cardinality of R divided by S? What that will be? That will be 0. Okay, when it will happen? When there is no A value which is pairing with every SB value. Yes or no? Do you agree? See, this will happen. This will happen when no A value is pairing with every S value. I can say this will happen when when no A value when no A value pairs with pairs with, when no A value pairs with all S values. Okay, so in this situation, you will get 0. This is very simple. Let me give you one example of also for this 0. For example, let's assume you have table A, B, and this is your table B. In this table B, let's assume you have B1, B2. Okay, now let's assume that this A1 is pairing with B1, but A1 is not pairing with B2. A1 is pairing with B1, A1 is pairing with B3, but A1 is not pairing with B2. And let's assume A2 is pairing with B2, but A2 is not pairing with B1. And let's assume this A3 is not pairing with any of them. Okay, let's assume A3 is not pairing with any of them. Now you tell me what will be the answer. This is your table R, this is your table S. Then what will be R divided by S? What will be R divided by S? You know the result. The result will have attribute A. Okay, so the result will have attribute A. Yes or no? The result will have attribute A. But you can see that this will be empty table because there is no A value which is pairing with every S value. So this is actually empty table. So this is actually empty table. Okay, this is actually empty table. This QA. Simple, very simple. So this is your 0. Now what is maximum cardinality? Please tell me. Now what is maximum cardinality of R divided by X? What is the maximum cardinality that you can get? Tell me. See, very simple. If you want maximum cardinality, then just notice one thing. Let me tell you the answer. The answer will be the cardinality of R divided by cardinality of S floor value. Okay. Cardinality of R divided by cardinality of S floor value. Let me tell you why. Let me tell you why. See, I want maximum. Remember, I want maximum. I want maximum cardinality of R divided by S. Okay, R divided by S. Now let's assume, see, you already know that in this S, let's assume I have total M tuples. Okay, let's assume total I have M tuples here. In this S, I have B1, B2, and so on, BM. Okay, and in this R, I have AB. Okay, in S, I have B. So in this R, you just tell me one thing. You just tell me one thing. If one value comes here, if one value comes here, then how many tuples should come here at least? For every value here, at least how many tuples should be there in this table R? Are you getting my point? In the output, if I have A1, in the output, if I have A1, then because of this A1, at least how many tuples should be there in R? In the output, if you have A1, then A1 should match with every B value. Yes or no? A1 should match with every B value. A1 should match with every B value. Do you agree? So can you notice, if I have one tuple here, then at least M tuples must be there. Or you can say like this, that M tuples are giving me one tuple here. Okay, M tuples here giving me one tuple here. I want maximum value. Then what I can say every M tuple can give me one tuple. Yes or no? Next M tuple can give me another tuple. Do you agree? Next M tuple can give me another. Similarly, like this and so on. So for every M tuple, one tuple I am getting. Yes or no? Do you agree with me? I hope this point is clear. See, very simple point. Understand this point. This is very important and interesting. If you have RB, okay, and you have S which has B. In S, if I have M tuples, if I have B, okay, B1, B2, and so on, BM. Okay, then remember, in the output, in R divided by S, that is Q, that is QA. Okay, so in the output, if you have some value, then in the output, if I have A1, then what should happen? This output, this A1 is in the output. It means A1 is pairing with every B value. It means I can say this A1 should pair with every S value. This A1 should pair with every S value. Okay, it is like very simple point that M tuples, they actually give you M tuples, they actually give you one tuple in the output. M tuples, they actually give you one tuple in the output. Okay, one tuple. m tuples become one tuple in the output. Is this clear? So finally I can say, if you want maximum, then every m tuple can give you one tuple. Okay, to get maximum cardinality of R divided by S. If you want maximum cardinality, okay, then what can happen? In this R, every tuples, okay, these are m tuples. Every tuples can give you one tuple here in R, in this Q. Okay, you know S has B or R has AB. Okay, so here Q has A. So here you can see that for every m tuples you are here, you are getting only one value. Okay, for the next m tuples, again you will get one value. Okay, and so on. The same thing will keep happening. Is this clear? Where, remember, what is this m? M is cardinality of S. Okay, m is cardinality of S. So very simple. So finally tell me, maximum, what is the cardinality? Maximum cardinality of the result, what that will be? Maximum how many tuples you can get? Maximum how many tuples you can get? Tell me, that will be very simple. Cardinality of R divided by cardinality of S. Floor value, yes or no? So the answer will be this. Okay, so very simple. So remember, if cardinality of R is N and cardinality of S is M, okay, then remember maximum cardinality of R divided by S, that will be N divided by M floor. Okay, or I can say floor of cardinality of R divided by cardinality of S. So this is the maximum. Okay, I hope all these points are clear to everyone. Very simple. Now you tell me, if S is empty, then what will happen? If S is empty, then what will happen? Just tell me. For example, let's assume RAB. Here you have A1 is pairing with B1, A1 pairing with B2. Okay. And let's assume A2 pairing with B1, A2 pairing with B3, and A3 pairing with B3. So let's assume this is the table. Now divided by S. But S table is empty. SB, that is empty. The answer will be QA, but this is empty. Okay, this is an empty table. This is empty table. Then tell me, what will be the answer? Tell me, can I say answer will be empty? Can I say answer will be empty? Very simple logic I am asking. Can you disqualify A1? Can you disqualify A1? Can you disqualify A1? You cannot disqualify A1. Yes or no? If you disqualify A1, then A1 will ask, what is my violation? Did I do some violation? Please tell me. Did A1 do some violation? Did A1 do some violation? See, there is no tuple here. So can A1 do some violation? A1 cannot do any violation, right? See, if you reject A1, okay, remember this table is empty. Because this table is empty, now if you reject A1, if you disqualify A1, then A1 will come to you and A1 will ask you, why did you disqualify me? Did I do any violation? You will say, no, you did not do any violation. Okay, because you cannot disqualify, so this will be in the output. Similarly, A2 will be in the output. Similarly, A3 will be in the output. Is this clear? Please tell me. Did you understand this logic? Let me know. Because we cannot disqualify them. Very simple. All of them will come in the output because, okay, they cannot be disqualified. Yes or no? They cannot be disqualified. There is no violation. They are not doing any violation. They are not doing any violation. So all are qualified. So all are qualified. Please tell me, did you understand this? So all are qualified. Okay. You can also see, if you want to see S is empty. Okay. If S is empty means you have R which has AB divided by S which has B. You know the result. The result will be A. Okay. Now, if S is empty, okay, this is given. Given is S empty. This is given that S is empty. Okay. Now you can use the Helly equation if you remember. Okay. Just use the Helly equation. Just if you remember the Hell equation, we have seen what is Hell equation. Find all A values minus disqualified A values. Yes or no? Find all A's minus disqualified A's. If you remember, this we have seen all A's. Tell me how to find all A's. All A's means from this R you find A, you project A. From this R you project A. These are all A values. Minus what are disqualified? Disqualified A values. I want disqualified A values. Then that will be what? Very simple. Ideal minus actual. Okay, what is actual? Ideal minus actual. Actual is R. Okay, actual is R. That you know. What is ideal? Ideal means A values should pair with every S value. Okay, so ideally, A values of R cross product with S minus. So remember, this is ideal, this is actual. Okay, so like this. Very simple. Understood? Now you tell me, if S is empty, then what will happen? Because S is empty, so what will happen? Tell me, if S empty, then what will be cross product with S? Let me know. If S empty, then can you tell me what will be R cross S? That also will be empty. Yes or no? Do you agree? Okay. So if S is empty, then R cross S, that also will be empty. Cross product also will be empty. That you already know. Okay. Because you know, see, one more thing. You can notice that cardinality of R cross S, that is equal to cardinality of R multiplied by cardinality of S. So you tell me, if cardinality of S is 0, then what will be cardinality of R cross S? That also will be 0, right? So you can see, if S is empty, then R cross S will be empty. So you can see, because S is empty, you are saying S is empty. If S is empty, then what will happen to this cross product? Then what will happen to this cross product? What will happen to this cross product? This also will be empty. From empty, if I remove something, what I will get? Empty minus anything. Okay, please tell me. If I do empty minus anything, that also will be empty, right? Okay, empty minus anything, that also will be empty. So again, this thing also will be empty. Okay, now you tell me, anything minus empty, what that will be? Anything minus empty, that will be same as R. Yes or no? That will be same as R. So I can say that finally you will get this minus empty. So finally you will get unique A values of R. That's it. Your answer will be all the A values of R. Is this clear? All the A values of R. Please tell me. Let me know. So very simple point. Here, let me write it here. So remember this note. Okay, this note you remember that if you have R which has AB divided by S which has B, this this will be A. If S is empty, if S is empty, then remember, then R divided by S will be equal to all A values of R. Okay. Okay, is this clear? Basically, all A's of R. I hope this point is clear. So tell me, what will be the maximum cardinality of R? R divided by X. What can be the maximum cardinality of R divided by S? And what can be minimum cardinality of R divided by S? Tell me. What can be maximum cardinality of R divided by S? All A's of R. Maybe A's are unique. Okay, then the answer will be cardinality of R. If all A's are unique, yes or no? If all A's are unique, do you agree? If all the A's are unique, then you will get a cardinality of R. Okay, what is the minimum? If R is empty, okay, if R is empty, then you can get a 0 if R empty. If R is empty, then you can get 0. Okay, very simple. So we have done the complete analysis so far. I hope you understood this. Is this clear? So the division operation is very important. We have done the complete analysis of division operation. Okay. If R is itself is empty, then what will happen? Let me know. If R itself is empty, You have R AB divided by S B. This is equal to QA. If R is empty, then what will happen? If R itself is empty, see, this will give me those A values which pair with every SB value. Please notice this division operation, what it will give me? It will give me those A values which pair with every S value. Do I have any A value? You know the result is QA. You know the result is QA. If R itself is empty, is there any A value? If R itself is empty, is there any A value? There is no A value. So if R is empty, then R divided by S is empty because there is no A value at all. Understood? If R is empty, then R divided by S is empty because no A value at all. Because there is no A value. Because there is no A value at all. Okay. I hope all these points are very clear. Now let me tell you one theoretical definition of division operation. This is a very small topic. So let me quickly tell you theoretical definition. This is a theoretical definition of division operation. Basically, I want to tell you why this is called division. This word division, why it is called division. So let me quickly tell you. You know mathematical division, right? Do you know mathematical division? See the mathematical division, if you understand. Okay. Now, for example, if I ask you what is 7 divided by 3, can anyone tell me what that will be? 7 divided by 3. Only give me quotient. Only give me quotient. Don't give me remainder. Only give me quotient. Don't give me point or something. What is 7 divided by 3? That is 2. Yes or no? For example, if I ask you, what is 14 divided by 3? Let me know. Only give me quotient. What is 14 divided by 3? That will be 4. Can you tell me why? Can you tell me why this is 4? Okay, because did you notice that this is the largest integer such that 3 multiplied by 2 is less than equal to 7. Okay, please notice this definition. You notice that if I have some number, okay, I have some, let's assume m divided by n, this is equal to quotient q. Then what is this quotient q? Why this quotient is q? When this happens, it means q is the largest integer. Q is the largest integer such that n q is less than equal to m. Do you agree with me? Here 2 is the largest integer such that 3 multiplied by 2 is less than equal to 7. Did you understand? Very simple point I am asking. See, I am asking that in the mathematical division. Okay, you just tell me about mathematical division quickly. In the mathematical division, let's see this one. Like, let's assume 18 divided by 4. Tell me what this will be. This will be 4, right? Okay. Okay, just find the quotient. So you can notice 18 divided by 4, that will be 4. Why this is 4? Because this is the largest value such that 4 multiplied by 4 is less than equal to 18. This is the largest. This is the largest integer such that 4 multiplied by 4 is less than equal to 18. Agree? Yes or no? For example, if I ask you what is 16 divided by 8, that will be 2. Did you notice this is the largest integer? This is the largest integer such that 8 multiplied by 2 is less than equal to 16. Is this clear? This is mathematical division. I hope you understood. So if you have m divided by n equal to q, okay, then q is the largest integer such that nq is less than equal to m. Did you understand? The same thing you can say for division operation. Now let's come back to division operation. Now let's come back to division operation in relational algebra. Okay, you can say the same thing. Means, tell me. If I have r divided by s, then what can you say about this? R divided by s. The result will be q. What can you say about this q? R divided by s. The result will be q. What can you say about this q? This will be the largest relation, remember, this will be the largest relation. Please understand, this will be the largest relation. This will be the largest relation such that Q cross S, this will be subset of R. This is the definition. Is this clear? Please tell me. Let me know. Did you understand? See, very simple. You know mathematical division. In the mathematics, the division you already know. If you have integer a comma b, then what is a divided by b? This is the largest integer q such that q multiplied by b is less than equal to a, right? Yes or no? A divided by b is equal to q. Then this q is the largest integer. This is the largest integer such that b multiplied by q, or I can say q multiplied by b is less than equal to a. The same thing you can say for relational algebra division operation. If you have relation instance a comma b, if you have relation instance a comma b, then a divided by b, that is largest relation. Remember, a divided by b, this is the largest relation q such that q cross b is subset of a. That's it. You can see here in the division, you can see. Please understand, in the mathematics, what happens? A divided b, that is maximum integer such that qb is less than equal to a. Okay, in mathematics. Now you see in relational algebra, this a divided by b, this is the largest relation such that q cross b is less than, is subset of a. Okay, is this clear? Now, okay, here this is your cross product. Here, this is your cross product. I hope you understood this. This is your cross product. Please tell me, did you understand? Let me know. Okay. So, very simple point. So, remember, please understand, R divided by S. This is the largest relation such that T cross S is subset of R. Very simple. We have already seen. Quickly tell me the answer for this question. For any relation R comma S with disjoint schema, means R comma S, they have disjoint schema. Like let's assume R is AB and let's assume S is C. Okay, then tell me the answer for this question. R cross S divided by S. Remember, R cross S schema will be ABC. Divided by S schema will be C. So what is R cross S divided by S? That will be R. Okay, you can check it. This is very simple, very intuitive. R cross S divided by S, that will be R. Okay, next, what is R cross S divided by R? That will be S. Okay, R cross S divided by R, that will be S. Very simple. Now let's move on. Okay. For any relation, these are the relations. Please understand. R, A, B, S, B. Okay. If R divided by S is Q, okay, R divided by S, that is Q, then can you say that Q cross S is subset of R? Can I say this? Please tell me. Let me know. See, very simple. R is AB divided by S is B. The result is Q. Can I say that Q cross S is subset of R? Can I say Q cross S is subset of R? Can I say Q cross S is subset of R? Then Q cross S is subset of R. Can I say? Can I say Q cross S is subset of R? The answer is yes. Okay, you already know. You already know that if this happens, then actually Q is largest. Actually, Q is largest relation such that Q cross S is a subset of R. Okay, so very simple. So this will happen. Very simple. Now you tell me the answer for this question. R is AB, S is B. R, AB, S, B. Y is a relation. Y is a relation such that Y cross S is subset of R. Can I say Y is division? Did you understand? R is AB, S is B. Y is a relation such that Y cross S, that is subset of R. Such that Y cross S, that is subset of R. Now can I say Y is R divided by S? Can I say? Can I say Y is R divided by S? Answer is no. Okay, because Y must be largest relation. This condition is there. Okay, Y must be largest. Okay, this condition must be there. Y must be largest. Okay, in the same question, if I change and if I write this, that Y is largest relation. Okay, R is AB, S is B. Y is the largest relation such that Y cross S that is subset of R. Now can I say, now this is true. Now this statement is true. Okay. So that's it. This is your chapter. We have completed relational algebra summary. Everything we have seen in the relational algebra summary, part 1, part 2. This was part 2 of relational algebra summary. I will provide the link in the description. You can watch part 1 also. We have seen all the basic operators, all the derived operators, outer join, division operation, inner join, everything we have seen. Please tell me, did you understand? This is the complete summary of division operation also. We have seen what is division operation, how to calculate division operation result, what are the different implementations of division operation. We have seen multiple implementations of division operation, and we have seen the theoretical definition of division, why we call it division. Because remember, R divided by S, that is equal to Q. Here Q is largest relation such that Q cross S is subset of R. Okay, so this is why it is called division operation. Very simple. So everything we have seen, let me tell you, every important point, every result, every theorem, every tricky question, every variation we have covered in this session. So this is your relational algebra complete summary. I hope you loved it. Please share your feedback in the comments. Okay, please like this session and please share your feedback in the comments. Okay, thank you everyone.